All right. Yo, what's going on, team? Sorry about the lack of an intro screen, but we all know what we're here for. 2024 Maths Extension 2 HSC exam. This is the second time I'm running this. Honestly, I still haven't taught the course to any cohort, the new syllabus. So we'll see how we go. And yeah, I hope you enjoy. And if you're watching this VOD in the future, I hope the insights and the thought process can benefit you as we struggle through this paper. Yeah, welcome everyone. Right, so I'm just gonna set the time. Let's start at around 5:40. Just picked up this paper from the exam room and haven't looked at it at all. Trust me, no cap, guys. There's no preparation for this. Honestly, I haven't practiced any Extension 2 work for the last year, so will we do any better than last year? Probably not, but can always hope. Hope the paper's easy. Hope that if you're just coming out of the exam right now, that you're having a good day, and if not, just let the scaling take care of you. Just remember, anything over 50 is probably a band, 80 plus. Anything over 65, very likely to be in top band E4. So, let's see how we go. I'm going to set the start and end times for the exam conditions. So we'll make it 5:40 with 10 minutes reading time. Yes, let's make sure I actually know how to do 24-hour time. 5:40, that means we're going to end at 8:50 after reading time. And I haven't actually done multiple choice A. That's just the document that, yes, we do not know that multiple choice is A. All right. So in a couple of minutes we'll get started. So for anyone walking out, oh, let's go. The goat has returned. Love the Shakespearean you got there. Code Rorik. Did you have the exam today yourself? Hope it went well. Is goat a good thing? I hope it means greatest of all time, which I'm not sure you can say that anymore about me. I'm sort of like a bit of a deadbeat when it comes to maths. I'll just start at year 12. Awesome. Well, I don't know if you think like looking at this is spoilers or not, but hey, between now and when you actually do this exam next year or for your practice, you'll probably have forgotten everything, eh? So probably entertainment for you at this point. Was the last question T equals 1 over K? Bro, I have not seen the questions yet, okay? I don't even know what topic it's from. So you might have to check back in 3 hours when we actually even make it to the paper. That paper was diabolical though. Okay, all right. Got one non-enjoyer of the 2024 HSC. Bummer. It's not good to hear. Got a couple of minutes before we start reading time. Online version for anyone that wants. Oh yeah, I mean, I don't know if we can do links, but obviously refrain from doing any linking of anything that's actually not relevant. Yeah. Okay. Yeah. I do have moderation, so if anyone does something sus on the chat, we'll be able to police you and make you behave yourself. I bet Ringo, my bro Ringo is probably working on the solutions right now, but I'm not sure he's done with them yet. Chances are, like, my efforts on the last question will not be as good. Like, I think he'll probably have a pretty polished solution by the end of this evening, and he'll probably have it published on the borderstudies.org forums, if not anywhere else. The folks at the Mansoir page are probably also working on it as well. So yeah, this is just for entertainment, guys. A minute to go till the reading time starts. Yeah, well, so far we've got one person saying that the paper was diabolical, but, I guess we'll be the judge of that. Just make sure my iPad actually works. So we got to change the scene at various times from looking at the paper to looking at the iPad where I'm trying to write the solutions. So let's just write the heading, I guess. Oh, what's with that color? That color is diabolical. Let's do this color. I better get myself a real pen. I'll just be right back. 20 seconds. All right, guys. Just give me a second. That's a pencil. Great. Probably should get a calculator as well, eh? Way too easy from Maurice. Okay. Damn. Code typers from 2023 cohort. What did people think of this paper? All right, well, we're about to find out. So my reading time has started, and let's have a flick through, suss out what's going on. So this is my opinion about reading time and how you use it. I personally don't look through the multiple choice trying to solve them. I just assume that anything up to about question 7, question 8 are very approachable, with various techniques of multiple choice. Just not going to bother looking at them. Okay, poorly, interesting. Now, we'll look at question 9 and 10. You can see that 9 is complex numbers, and so is 8. Okay, great. So hopefully we got some complex number enjoyers. Code Rig's year 12 mate said it was all right. Okay, that's a promising thing. Let's check out the question 10. Vectors in 3 dimensions. So that, oh great. Okay, well, I'm not looking forward to this one. We're going to spend a few minutes on this one, I think, question 10. Let's have a look at the 11s. Nothing special in 11s. Okay. 12s. We got some vectors. Oh, I should actually know this. This is the projection, isn't it, guys? All right, just kidding. I do know this. I taught extension 1 before. Okay, we've got partial fractions. Okay, fine. Consider the equation. Yeah. Look, we're still gonna get bogged down in various parts. Explain. Oh, okay. Chat, any proof enjoyers in here? I know that everyone hears the word proof and they start sort of, eating themselves. Yeah, but we'll see how this one turns out. It's only question 12, so surely it can't be too bad. Okay, 13. Another vector equation of a line. Bit of magnitude business. Nothing crazy. A simple harmonic with a shift to center. Not a problem. Horizontally on a straight line with the resistance proportional to the square of the velocity. Should be pretty cruisy. And oh, thank goodness they put a inequality at the end of question 13. We all know, chat, that when you get an inequality later in the paper, it could be anything, right? And it could be really nasty. So I hope this one's fairly doable for everyone involved. Question 13. I don't know if my camera's a bit blurry, but yeah, Steph loves proofs. I can tell. Yeah, brah. Zeba, brah. Exactly. Okay, another proof, question 14. Okay, I'm glad that we have people in chat that are proof enjoyers. That's good to hear. We do have a argument question, interesting. Mathematical induction with an inequality and some, binomial expansion, binomial notation, very interesting. Ooh, you know what? Somebody else on the forums last night, Board of Studies, going, yeah, we haven't actually seen a proof where we have a student explain what's wrong with the argument. That person caught it. I don't know if he has any insider info, but damn, he was spot on. We actually got a proof that asked us to disprove some argument. Fantastic. All right, so 14 keeps on going. Oh, wonderful, a collinear question. You know what's really funny today? I was actually teaching extension 1 earlier today, and I was like, oh, guys, we got to demonstrate collinear. So I decided the first example that I was going to do with my class was to prove that the centroid of the medians meet at the centroid. And you know what's bad about that? Is that the medians meeting at the centroid is actually damn hard to prove with any type of argument. You're going to spend ages finding the ratio that's required for the medians to meet at 2/3 through their length, right? So this doesn't look too scary because it's literally the same principle as proving the centroid of a triangle. So we'll see how that goes. Just dropped 99 raw. Sheesh. Bro, how do you know this? Parik R. Damn, okay, samesies from Steph, wonderful. Okay, so we got some more vectors coming up from question 15A. Damn, they just threw 6 marks on vectors on 14, and then here comes another 5 marks on vectors in question 15. Okay, look, vectors is a fairly new topic. I'm pretty rusty on it myself, so we'll see how we go when we get to question 15. We got a reduction formula, nothing crazy here, hopefully. Interesting, a magnet So I can see that they've gotten out of the silly projectile motion with resistance now. That's not too bad, unless they put one later on. Use a substitution, find... Okay, having this at the end of 15 kind of scares me a little bit, because I'm sort of looking at this going, this better be a smart substitution. If it's like a substitution that sort of like is obvious, why would they put it at the end of 15, right? Surely this is something crazy, okay? Do you know where I can get a hold of the paper? I reckon like try Board of Studies, like .org, the forums, but it's full of ads, so I don't really know. And there's question 16. Consider the function. The function y equals, okay, so it's got like a cos graph with a circle and tangential to a circle. Okay, all right. I guess we can see where this is gonna go later. And it's 4 marks with no scaffolding. The vector, I might just read this because we've got about 4 minutes left, so I might as well read all the question 16s and see if there's anything that students can actually access here. Okay, the value of kn has been chosen so that a circle can be drawn centered at the origin. Okay, so they chose the period purposefully has exactly 2 intersections with the graph, so that the circle is never above the graph. The point AB is the point of intersection, and A is greater than 0 and B is greater than, yeah, okay, so everything's on the diagram. The K, obviously you can't see, but it's probably here on the shown in the intersection point. The vector joining the origin to the point AB is perpendicular to the tangent of the graph at that point. Do not prove this. Show that K is greater than 1. Is that what old mate on chat was saying earlier? I think he said something along the lines of T equals 1 over K. I think that's later on. Yeah. Look, okay, this doesn't look too bad for 4 marks. I'm sure people can make some progress and get some marks in this. Question 16A. 16B, roots of unity. This looks pretty standard. I mean, we've seen these tons before. If you go over the old HSC papers, there's like a shed load of them. But I'm actually, yeah, the interesting thing here is it's got a bit of like a progression of powers, which is, you know, new. I haven't seen that before. So that will be interesting. We're looking forward to doing that if we can make it this far. And question 16C, what? They put another mechanics question on 16C? Hey, everyone thinks mechanics easy, right? Like, you know how like when you ask people what's the easiest to hardest topic, everyone's like integration, mechanics, easiest topic, and then vectors and proofs. So this year they decided to chuck a mechanics on, and we've already got folks in chat going, yeah, T equals 1 on K, find the time taken for the particles to meet. I mean, there's no scaffolding. I'll just quickly read the question. Two particles, A and B, each have mass 1 kilo, are in a medium that exerts resistance. Okay. Okay, so linear resistance to the velocity. Yep. Both particles maintain vertical trajectories. The particle, due to gravity, is... I shouldn't be picking up a pencil, shouldn't I? That's like non-writing time. The 2 particles are simultaneously projected towards each other with the same speed, where this... I feel like I've seen this. I've seen this in some ridiculously old book. Like, this was in some textbook, like really, really old, back in the 90s. Like, this is not original. I don't know if you guys have seen this before, but yeah, it's like not original. Because when you have the 2 particles simultaneously projected towards each other, you obviously have to develop their velocity function separately, because one's going up and one's going down. You got gravity as well. Okay, so, and they've defined gravity to be probably less than the terminal velocity. Fantastic. So the particle A is initially d meters above particle B, where d is less than, okay, because if I'm guessing if d is greater than that, they probably won't meet. Find the taken for the particles to meet. I don't know about this, guys. I feel like this is very doable. I mean, hey, we'll find out when we get to the end, all right? Compared to the, you know that paper where they had like the nasty complex numbers region last year, and then the year before they had like some stupid like triple simultaneous equation with 3 complex numbers. I think this should be, you know, like people can get 1 or 2 out of 4, right? If they've learnt the topic, like, right? So is this easier than the 2023 paper? Look, I have not seen anything, cool cat, in my reading time. I'm about to start writing in about 30 seconds. That that tells me that this is any harder than last year. I would say that this paper is more approachable than last year's paper. So just from the reading time alone, I'm going to say it's easier. I want to say that you're going to need a 65 plus to reliably get a band E4. So maybe by the end of the 3 hours, I might have a different opinion, but we'll find out. So it's 5:50. We're going to start our writing time. Now in the writing time, I still do my multiple choice first. I know there's like a recommendation. Any question 11 first enjoyers in here in chat? I'm multiple choice first, definitely, every single time. Okay. Which of the following vectors is perpendicular? Oh, great. I mean, like, let's get going. So we just want the dot product to be equal 0. So we have to test each one because that's what multiple choice questions are about. Okay, so let's go. We've got 3, 2, minus 5. We're going to try it with minus 1, 1. Times them together, the dot product is not. So A is out. Let's look at B. We got 1, 1, minus 1. Nah, it's 10. That's no good. The dot product's not... Yeah, okay, let's do the next one. Minus 2, 3, 1. Okay, so we got a... Yeah, nah, that's 5. That's minus 5. That's terrible. So they made you try everything. Okay, so 3, minus 2, 1. So you got a 9. You got a minus 4, and you got a minus 5. Oh, obviously it's D. Okay, so I just love it. Like, they're testing your multiple choice technique. I mean, maybe you should maybe in the future, everyone should test these answers backwards. I want to start filling out the multiple choice answers. So 1 is A, D, sorry, obviously. Just going to type that in. Great. Okay, number 2. Which of the following statement written in the language of proof consider? I don't want to read this. Which of the following best represents this statement? Okay, so we got for all angles between pi on 2 and pi, there exists another angle between such that. Did they just use a semicolon? Semicolons are only allowed in 4-unit English, guys. If you're using a semicolon in maths or in advanced English, you're just being pretentious. Okay, guys, it's probably a colon in most textbooks I've seen, but whatever. Such that this, there exists a theta in the second quadrant. Yeah, okay, no. Are they serious? They just want you to interpret this that's it. There's no meaningful actual thought. I thought you had to actually prove this is true or false, but whatever, it's C. Let me just say, yeah, I mean, you can't read these sentences backwards, even if you really wanted to. You have to read these sentences from left to right. So, I mean, how can it be anything else? So we're gonna pick 2 as C. I just want to double check if there's any weirdness going on in the question 2. It shouldn't be. Exists. You can't have there exists when you have there exists happening in the second part of the statement. So there's number 2 done. Number 3, consider the statement. If a polygon is a square, then it is a rectangle. Wonderful. Is the converse. If the polygon is a rectangle, then it is a square. So 3 is A. Oh, they're really giving out free marks today. Yeah, we read. We can read. It's not contrapositive, guys. It's fine. Okay. Sometimes you the question's too easy. You get paranoid, right? A monic polynomial degree 3 with real coefficients has 3. Okay, real coefficients means you have 3 and 2 plus I and obviously 2 minus I. The conjugate root theorem. Which of the following could be f of x? Now, because they're giving you the choices, you first check the sum of roots. Okay. And that's going to be 3 plus 2 plus 2 is 7. So that means that you're gonna rule out C and D because the sum of roots has to be positive 7. Now the product of roots, which you're going to do is 3 times 2 plus I times 2 minus I. That's going to be 3 times. That's no 2 plus 4 plus 1. So it's going to be a positive 15. Now let's just go over these two. Remember, you got minus B on A, C on A, minus D on A. Minus D on A has to be 15. A is 1. So D has to be negative 15. And we're going to have to pick B. So number 4 is B. Okay, fantastic. We got number 4 done. 5 particles moving in simple harmonic motion with period 10 seconds and an amplitude of a. The particle starts at the center point of motion and is initially moving to the left with a speed of this. What will be the position? I'm a bit rusty on this. Initially moving to the left with a speed of v after 7.5 seconds. Period of 10 seconds. I'm going to just draw a simple harmonic diagram with an amplitude of 8. So we've got 8 here. Let me think. Don't tell me they want us to use, like, quote the formula, because that would be rude. After 7.5 seconds. I really don't want to write like an equation, guys. I don't want to write an equation, but I feel like they're making us do it, so whatever. We're gonna treat the center as 0, okay? And initially moving to the left with speed v, so we're gonna go x equals to, do I even know how to do this anymore? Like, we're gonna do minus sign. Period is 10, so 2 pi on n equals to 10. N equals to 2 pi over 10, which is pi over 5. So we got pi over 5 t. And the amplitude is 8, so by the time like t is on the extremes, we got minus 8. Okay, so speed of v. Why do they care about this? Am I like cooking too much here? Surely it's not that hard. So let's just put 7.5 in there to get the position. Okay, so 7.5 on 5 is pi, so that's 3 on 2. 3 on 2 pi. And 3 on 2 pi is -1 in the sine function, so it's going to be position 8. And it'll be 8 to the right of the central point. What? And there's only one of these as the correct option. Let's just do, let me just check this one more time, right? You see t equals 0, you're at the center, and the graph starts going left. I'm not suspecting anything yet. Let's just do x dot just in case. We got, yeah, but if you're at the end, you're gonna have a velocity of 0 anyway, so what's the point, right? Like this whole v thing is pointless. I mean, I think it's just asking us for the period, really. Okay, so after half a period, think about it, guys. When you're at the center and you go from here, back to here, back to here, that's 1 period, so 10 seconds. So every 2.5 seconds, it does this. So that, and that, obviously after 7.5 seconds, we're over here. So I didn't need this in the first place, right? That just shows how rusty I am with simple harmonic motion. So we're definitely at the D for question 5. And that took a bit longer than I expected, actually, for D. That was shocking. Sorry about that, guys. 5 is D. All right, 6. A light string passes over a smooth pulley. Attached to the ends of the string are masses as shown. The acceleration due to gravity. What is the acceleration of the 9 kilogram mass? So this is one of those ones where you've got 9 kilograms going down, so there's 9g. I mean, if you treat up as the positive convention, we've got minus 9g. You've got the 5g. Now the pulley obviously changes the direction, but the real direction is up by 5g. So the overall acceleration, adding these two combined, you can say the F net, if you treat up as positive, equals negative 4g. And is that it? 6 is D. Okay, great. What on earth are these other options? Like, what do they think people will think about this? Like, come on. How would you even get 7 on 2? Like, guys, got prizes in chat if someone can get like 7 on 2, get it wrong, you know? This is crazy. 16 had been sobbing, by the way. Okay, let's just have a look at in chat. Don't worry, I'm not looking at the answers, bro. All these people. Okay, no, bro is wrong. Bro is wrong. Man, I'm getting gaslit. People are like, how is it D? Okay, well, I guess I'll have a look. Give me a second. All right, guys, everyone settle down. Yeah, actually, I'm the one cooking. Sorry about that. I was like, how can it be this easy, right? How can it be this easy? We got minus 4g. Let me think about it. Also, we got a problem though. Like, am I just completely cooked on like pulleys? Man, shows how long I've done this, since I've done this. Minus 9g. Yeah, gravity's acting on the mass. And then the other one is acting on the 5g. So what I'm actually concerned about at the moment is that these are the forces. That's a force. So how can you call it the acceleration? And why is it g? Like, I thought you take the g out when you do the acceleration. Or like, what's going on? I'm gonna like circle 6. I want to come back to it because I've got a question mark on question 6. Like, it can't be that easy. And then you got people in chat telling me I'm wrong. So like, I'm just put a question mark next to it, okay? And yeah, question marks, question 6. I reckon people are gonna be like jumping up and down saying this is wrong, blah blah blah. All right, let's just go. We'll go back to it. It's given that this one, okay? So we've got z minus I minus I, 1 minus I equals to 2. So we've got something centered at 1 minus I over here, okay? So 1 across, 1 down, and we have the circle with radius 2. Okay, so we've got a circle like this. What is the maximum possible value of the the magnitude? Sorry, the modulus of z. Look, this is not too bad. This is 2, and this is root 2. So 2 plus root 2 will be the maximum value, and 7 will be c. Yeah, people like, bro, people are all like jumping up and down telling me it's wrong. Clearly, you guys probably know better, okay? Obviously, I'll have to like go and justify to myself why 6 is wrong. So, you know, feel free to dock a mark off me. We're not going for our state ranks here today. I would have walked past this and be like 4G and like be like, that's it. But I know something's wrong because there's like G. Why is acceleration G? Maybe I just don't know pulleys. That's it, you know? All right, let's move on. Question 8. Euler's formula. Excuse me, really? They want us to do this. E to the x plus iy. Oh, minus iy, my bad. That's going to be e to the x. So we got a real number. Wait. Which of the following is equal to e to the z bar? But it doesn't have any of these, so I'm guessing we're gonna have to play around with the z. Okay, so in my opinion, in these situations, I think it's actually better to check each of these out. So e to the z. I guess the difference between this one and that one is it's you got e to the z in all of these, right? If we divided this through, it's not gonna work. These guys are out. C and D are out because you've got things that mess it up. Okay? Bro, it's C, it's B. I don't even know what it. bro, guys, trust. It has been suggested 8 is out of syllabus, but even if it is, doesn't matter. Oh, Ty jumping in. Hey, thanks, brother. Yeah, look, I know this is a bit out of syllabus, but I think we can test enough to make it work. Yeah. So e to the minus z, let's give it a go. We know C and D are out because none of these things actually worked, right? And we know this is the goal that we're trying to go for. So e to the minus x minus iy. Okay, so that's 1 on e to the minus e to the x. It's still not going to give us that. So we're going to try the last one. What? Okay. E to the z. They want the... Yeah, no, this is the one. Yeah, no, of course it's A. But like, come on. So what happens is when you do the conjugate of e to the x, e to the iy, what happens is the conjugate symbol takes over the e to the x because that's just a real number, so it doesn't really matter. And we have e to the iy conjugated, which is just e to the negative iy. And that's totally fine. Okay, fantastic. So we know that is definitely A for question 8. Yeah, look, guys, I know my complex numbers, so I'm pretty confident 7 is C. 6 is a big question mark because clearly like my pulleys knowledge is a bit like scuffed. Question 9, consider the solutions of the equation. What is the product of all the solutions that have a positive principal? Oh, don't make me have to, oh, come on. All right, guys. I hate when they make you do like working out questions like this. So we got 9 cis pi plus 2k pi. You got r to the 4 cis 4 theta, and obviously 3 is everywhere, right? So that's fine. Now let's have a look through all the various answers. I really don't want to have to do this. So 4 theta, let's make a list. We got pi, 3 pi, 5 pi, and 7 pi. Okay, so theta equals to pi on 4, 3 pi on 4, 5 pi on 4, and 7 pi on 4. We don't obviously care about these guys because they're out, right? So all we have is we have 3 cis pi on 4 and 3 cis 3 pi on 4 as our two roots, and we just times them together, which means we get 9 cis good old pi, and that's obviously -1. So we have what? Oh yeah, sorry, root 3, my bad, because the modulus is root 3. So 3 cis pi, -3. So we're on a B for question 9. Look, hey, we'd rather a question that makes us do some work and get it out than a question that we don't understand at all, right? So question 9 was fairly approachable. Question 10, 3 unit vectors in 3 dimensions are to be chosen so that A is perpendicular to B and B is perpendicular to C. What are they on about? And the angle between, okay, all right, let me just draw this. Okay, so we've got A is perpendicular to B. So let's just say this is B. That means A could be like, say, that one, or just anything in a plane that's perpendicular to B. And B is perpendicular to C, so C could also be in that plane. And the angle between, okay, so what we have, right, is I'm going to draw you guys a plane. This is a plane. And this is the plane that B is perpendicular to, because it seems like, so A and C are anything on this plane because they don't really have to have any sort of restrictions between them. So you could sort of turn it around in a circle and A and C could be anything. And the angle between A, oh, don't tell me you have to do A plus B plus C. Come on, they're unit vectors, right? So I have to add them, really? Is as small as possible. What is the value of cos theta? Is this an algebra question? Oh, please don't. Don't do this. Don't do this. It's an algebra question, guys. All right, guys. All right. I thought there was an intuitive, like, graphical way of interpreting this, but it's probably just going to be this, right? A dot A, A dot B, which is 0, and A dot C, which we don't know. This guy is 0, it's out, and that's whatever, it's like 1. And let me just have a look. Yeah, but how are we going to get the magnitude of vector A plus B plus C? That's also a bit troublesome, actually. I'm actually worried about this. Okay, A plus B plus C. Yeah. I have a feeling what this is going to be. So that's 1, and that's A dot C, and you want this so that the angle between A and A plus B or C is as small as possible. I want to draw a bigger one. How are we going for time? Oh sheesh, we're about 20 minutes in. This is not good. B. Okay, how do we make it so that the angle between A, let's just choose A here because we have to, right? And we're going to have to like choose A plus B plus C, so the angle between the sum of these and A as small as possible. So right now we've got a 90-degree here. If we chose C so that we're going backwards, what happens then? Well, then it's just like B, so it's 90 still, okay? If we chose C, so it's like kind of like making an actual number plane with that, like the 3D, normal 3D sort of axes. What happens then? If you do that plus that, you get a little square and you get the diagonal of the square. and the angle is the angle between A and the diagonal of the cube. I'm not so sure about that, but let's try maybe make C a bit closer, so that way you end up with a parallelogram. But then this gets a bit longer, like when you do the sum, and I think it's gonna warp the parallelogram just a little bit, and I feel like this will just make the angle worse. So this is gonna be a wild stab. I'm gonna suggest that C is the chosen, so that A and C are also perpendicular. Okay, so we've minimized A dot C, and therefore we've minimized this dot product. So I'm just going to write the dot product out. This is going to be A plus vector A plus B plus C and cos theta. Okay, and we know that this equals to 1 because A dot A is 1 plus A dot C. And I have a feeling that to make this angle as small as possible, you see, the thing is, as when you get smaller and smaller, right, cos theta will get bigger and bigger. So you want as big as possible for this. How do we do that? I almost don't like this idea of making them perpendicular. So let's just have a look. Which one's the biggest answer here? Cos theta. I'm struggling, even if it's a cube, I'm struggling to visualize this, guys, and we're about to 20 minutes, so I'm gonna have to like move this on. Okay. Root 2, and then we got a 1, so it's root 3, and the angle between that and that. Oh, don't do this to me. Am I actually not looking at the right angles anymore? I don't even think I'm looking at the right angles. I want to go back to 10 later because that looks hard. So question mark on the 10. I'll try not to get spoilers. What did I get for 10? We got VU going, pretty sure it's D. What'd you get for 10? Damn it, people love 10. Sheesh. Okay, can I come back to this, Rashi? Because I'm actually stumped. Like, all I come up with is that they want this, and they want this as small as possible, but I'm struggling with this fact that we've got this thing over here. I'm sort of like toying with the idea of squaring both sides, but even then it doesn't look good. It doesn't look good. So I'm a bit stumped on what to do with this one. I'm gonna come back to this with a fresh mind. We spent 20 minutes, 22 actually, on the multiple choice, and I think that's enough time. It might be good to just like clear our heads by doing some written questions. So let's go to question 11. So yeah, you can see my efforts on multiple choice is probably an 8 out of 10, right? Like 6 is wrong, according to a lot of people. So we're gonna go back to question 6 a bit later on. Let's do question 11. All right. Straight out of the gate, they chucked a integration by parts just to like test us. Great. So we're going to integrate one, we're going to integrate this one, the e to the x, leave the other one. Yeah, okay. Just warming up, guys. Yay. Moving along, B. I think we're on the right screen now, aren't we? B, so z equals that, so we got 2 plus 3i plus bracket 1 plus 5i because of the conjugate, and that's going to be 3 plus 8i. Okay, and that's part 1. Part 2. This is just to like kill some time till we have more time to go back to question 10. You know this, right? We're not going to let question 10 go. Z squared, so we have 2 plus 3i squared. So that's going to be 4 plus 6 is 12. 12i minus 9 minus 5 plus 12i. Yay. Moving on, we got question C. Find the angle between the two vectors, giving your answer in radians. Sheesh. So this doesn't look fun because we know the formula they're going for is u dot v equals to magnitude of u times magnitude of v times by cos theta. Okay. So we need to get the magnitude of u. Quickly doing this on a calculator. 1 squared plus 2 squared plus 2 squared is, what is that? 9? 4 squared plus 4 squared. Nah, we're gonna use the calculator. I'm not getting too old for this. 16 plus 49, 81. Really? Okay. Cos theta. And here we got the dot product. So 1 times 4, we got a 4 minus 8 minus 14 minus 10 minus 18. Yeah, minus 18. Great, and that's going to be a 3 times 9, 27 cos theta. Cos theta equals to minus 18 on 27, and luckily that's minus 2/3. Because cos theta is such a one-to-one function between 0 and 180, I reckon like we can just do shift cos on this one. Shift cos minus 2/3. And the angle is, oh come on, radians. They want radians, guys. Times pi divided by 180. Any enjoyers of the new calculator? I hate the new calculator. Anyone hate the new calculator? Like the new calculator has these buttons that toggle. I can't even teach kids how to convert into minutes and seconds with the bubble button anymore. I love the bubble button. Okay, so yeah, you know what? It is what it is. Okay, cool. Question D. We've got a lot of dive-ins. Going question 10 is D. ChatGPT-O got question 10 for B as well. Nice. You got to trust GPT, but you know what? GPTs tend to have like these really bad logical sort of flow in some of the answers. Yes. Me love melon. Help. Tears. Nice emoji there. I just ignore the fact that cos is as small as possible though as well. See, Jilly L gets B. So we got a whole bunch of people getting a bunch of different answers for 10. I reckon 10's the hardest question of this paper, unless I'm wrong about the later ones. We're going to find out, all right? So, evaluate. Oh, here we go. Here's probably a t result integration. I don't really see any way around it, so we're going to see if I remember how to do t results. We're going to go t equals to tan theta on 2. That means if we change these values, we got x equals to, x equals to from 0 to pi on 4, which is 1. Okay, so we got 0 to 1. And let's have a look at the actual sine theta. So sine theta is going to be, do I remember my t formula? I don't want to look at the reference sheet. I think it's 2t over 1 plus t squared. We've also got d theta, which equals to 2 over 1 plus t squared. Trust me on this one. Yeah, and I think we're ready to go. So we're going to change everything to the t's. 1 over 2t over 1 plus t squared plus 1 times by 2 over 1 plus t squared. I love the t result. In fact, this channel actually has a really old t result video that's been around forever. It has got good views, you know. All right, we'll just times everything through, and we got 2t plus 1 plus t squared dt, assuming I've made no mistakes. And I'm going to go 0 to 1 of 2 over, that's a perfect square there, t plus 1 squared dt, taking out time, t plus 1 square to the minus 2 with a 2 in the front, from t plus 1 to the power of -1 over -1 from 0 to 1. I don't know, like, do you guys find this kind of thing brain rot? Like, but you kind of have to do it accurately, just because if you don't get the marks you want. So you put 1 in and you're going to get a half, and you put 0 in, you're not going to get a 0, you're going to get minus a 1, right? So yeah, I'm always paranoid doing these kinds of numerical calculations, because I know that sometimes I get these wrong myself. Minus a half times minus 2, which equals 1. Yeah, I bet ChatGPT will be very good at these. All right, moving on. E. Write the number in mod arc form. All right, well, so this, I think everyone knows this so well by now. We just go r equals 2 root 3 plus 1, which equals to 2. And we've got the angle. So with proper working out, it looks like this. Tan theta equals to 1 on root 3. Okay, the related angle equals to pi over 6. And we know the quadrant, it's in the first quadrant. So we got theta equals to pi on 6. So in the modulus argument form, look, I'm sure the markers are happy to accept cis abbreviations. So cis pi on 6 for 1. Part 2, going to take that to the power of 7. So 2 to the power of 7 cis 7 pi on 6, okay, is z to the 7. And that's going to give us 128 cis 7 pi on 6. I'm going to now expand this out because I want to play it safe. So cos 7 pi on 6 plus I sine 7 pi on 6. We know where this is. This is going to be in the third quadrant, and the related angle is pi on 6. So cos of 7 pi on 6 will be negative. So we're going to have negative 128 times by the cos of pi on 6, which is root 3 on 2. And sine is also negative in the third quadrant, 128 times root 3 on 2 with an I at the end. So minus 64 root 3 minus 64 root 3 I for question 11E part 2. And question 11F, going to sketch the region defined by modulus of z is less than 3 and the argument of z. It's an and, so we do the overlap. Argument z minus I equals to, less than or equals to pi on 2. So let's just, whenever you do these arguments, make sure you put these empty circles in because the marking criteria might call for it and you might actually miss out on marks if you forget. So, okay, so we got a region. I love this new feature of GoodNotes. Guys, check this out. You can actually do a, that is awful. Let's try that again. Yay, okay, great. So we got a dotted line and that's the area inside that one. And we've got the z minus I. So I is round about here, right? That's I. And we'll put the axes labels in. And we want the argument between 0 and pi on 2. So basically anything that's kind of like going this way. So we put it blank circle. And we take the solid angle, so 0 is this, and pi on 2 is the one going up, and we shade in this stuff. Okay, so that's our region, I think. Man, I'm rusty on this. I'm not sure anymore. It's not like you guys who've been practicing day in, day out to get ready for the HSC. I'm actually I do this once a year. Question 12. All right, let's get to question 12. Let's have a look at chat. What's everyone doing? Wait, isn't sine? Oh boy, we can't even get 15 on that question. Thank you very much. Sheesh. The iPad makes it look like it never happened. Shout outs to Moralistically. All right, and Jilly J as well. Boy, Jilly L, sorry, my bad. Yes, sine pi on 6 is half. I was like, you know what's really funny? It's like when you're on Content Brain and you're looking at stuff, looking at chatting while doing this, you're not even aware. I was not suspecting at all on why the two numbers are the same when we have a 30-degree angle. I was like, yeah, they can be the same. They can both be root 3. I've seen this before. Am I right, guys? So yeah, thanks guys. Question 12. There goes another mark on top of the multiple choice marks. A part 1. Thanks, guys. Test looking a little light. Yeah. And you know what? I'm feeling that way, even though I flunked question 10 multiple choice and question 6. Apparently I know nothing about pulleys. So yeah, everyone's probably laughing at me going at home, this guy doesn't even know what a pulley is. Imagine him doing ramp pulleys, bro. No, settle kids. Okay, vector A and vector B is this. Find what? Do they just want us to dot product all of this stuff? So we got 2 plus 0 minus 12 over b dot b. So 2 plus, wait, I better know how to times. B dot b is 4 plus 16, okay, multiplied by vector b, so 2, 0 minus 4. I don't think there's more to it than this. 10 over 20. So it's minus a half. I'm doing some illegal maths here. I can't even be bothered writing the vector again. So we got minus 1 0 and 2. Great. Number 2. Show that. Alright guys, perpendicular. Do they really want us to just do all this again? So we're going to do alpha minus the answer from part 1. I can't even bother writing it. Equals 1, 2, 3 minus the answer from part 1, 0, 2. And we've got a 2, 2, 1. And we're going to take the dot product. We're going to do 2, 2, 1. Dot product with 2, 0 minus 4. And that's got to be 0, right? So we're going to check. So because it's a show question, let's just make sure we actually write everything. Equals 0. And here's the thing, because it's a show question, we best actually indicate what this is. This is vector A minus A dot B over B dot B. Dot product B equals to 0, therefore perpendicular. Guys, like something just like rubs me the wrong way about this question, because isn't this just the projection? Like, so if this is the projection, what's to stop some student from just mentioning that this is the, this is the vector, this is the perpendicular? Like, if somebody said, right, in their script that this is the perpendicular, right, to the foot of the projection, will they get 2 out of 2? I'm going to open this up to chat. What do you guys think? If someone actually gets clever and just be like, hey guys, this is just the foot of the projection as required, what do you think the markers will say about that? Yeah? So I wonder sometimes, like, they're going to have to give that, because theoretically it's true. Even without a diagram, this is getting to be a pretty well-known fact that this is the vector that's it's like, I mean, I can draw you a diagram if you're not sure, right, what I'm talking about. So we got, in 3D even, right? So you got vector A, this is vector B, right? And if you take the projection, which is what we found, this is the projection from part 1. So if you do the vector subtraction, obviously it's the perpendicular. Like, if you draw this diagram, I think the markers must give it 2 out of 2, because you don't need to be doing any calculations. Yeah, Jilly, I think so. I feel like they have to. I feel like maybe this is not enough, but this has to be a 2 out of 2 answer. So let's go. Keep going. Part B. Partial fractions to find this lot. So I'm going to dive straight into the split. X squared plus 1. I don't think I've ever had like an easy way of doing these. These are always tedious. Ax squared plus 1 plus x minus 1 bx plus c equals 3x squared plus 2x plus 1. Now if you look at this, it doesn't look like there's anything nice, so we're going to let x equals to 1. That leads us to, let's have a look, 2a equals to 1, so 3 plus 2 plus 1 is 6, a equals to 3. I'm going to rewrite that, so a is 3 now. I reckon another good thing to test is x equals 0, so I'm going to put 0 in, so we're going to get a, x equals 0, so we're going to minus 1 times by 0 plus c, so minus c equals to 1, so yeah, and a is 3 equals 1, c equals to 2, yay! Okay, so c equals to 2. And to get b, I think what we can do is we can just do the coefficient of x squared, which is 3. So we've got a plus b equals to 3, and that means b is just 0, because 3 plus b equals to 3, b equals to 0, and we've got the integral that we now can integrate. So a is, what do we got here? A is, I lost track of a, 3. And b is 0, and c is 2. So, yes. 3 marks, right? This is how we get our band E3s. And over here we got the inverse tan one, so plus 2 inverse tan of x plus c. Okay, cool. 3 marks. Easy. Number C, question 12C. Consider the equation. We've got a complex number equation with the modulus of z plus 8 plus 12i. Okay, what's this going on about? Explain why b. Do we really have to do the equation, like, or is there something clever about this? I almost feel like we'll just do the equation. So, yeah. And they want you to use a plus bi. They're not even polite enough to write a equals ib. So whatever. We're gonna go root a squared plus b squared equals to a plus ib plus 8 plus 12i. Getting dozing off here. So let's have a look at this. You can see that clearly we're gonna match the real parts. So the real part is obviously a squared plus b squared matches up with a plus 8. Okay, squaring both sides, which we are allowed to do logically. We've got a squared plus 16a plus 64, and these guys all cancelled out. Excuse me, where's all this going? What about the... Oh, bro, no, we don't need this yet. We can just do the imaginary part. The imaginary part basically says that the left-hand side is 0, and the right-hand side is b plus 12, so b equals to minus 12. Okay, sorry, I just thought there was more to it. Hence or otherwise, find z. Now we are in a position to go over here and actually solve this. So this is part 1 done. Now we're about to do part 2. We're going to sub the minus 12 into this. We've got a squared have cancelled out. Okay, so this is not a problem. And b is minus 12, so 144 equals to 16a plus 64. 80 equals to 16a. A equals to 5. All right, so a is 5. And there wasn't any quadratic, so I'm not too scared about this because luckily these guys are all positive, so there's nothing weird going on. And I think a is 5, b is minus 12, so therefore z equals to 5 minus 12i. Very approachable. I reckon like kids who've just done their first week of complex numbers can already get like almost 10 marks. In this exam, 10%. Okay, cool. So that's part 2 done. Let's look at D. Explain why there is no integer such that, so the phrasing is there is no integer n such that n plus 1 to the power of 41 minus 79 n to the 40 equals to 2. When you have this sort of phrasing, explain why no such integer exists, it calls for naturally proved by contradiction. So you indicate that you're going to prove by contradiction, and what you're going to do is you're going to suppose there exists an n such that this is actually true. Of course, this is just a setup. We actually have to figure out how to do the question. And people don't like proofs for this reason, because you got to actually independently come up with some way of arguing this. And most of the time, when you have these number theory, algebra-ish kind of questions, you kind of like try a few, right? You try a few numbers. Try 1. If you put 1 in there, you're going to get giant power of 2. And put 1 in there, you get an odd number. So you got this like, odd, even sort of question mark going on, right? And straight away, you know that this is a exhaustion by cases. So you say, suppose there exists an n, right? And then you go, if n is even, then n plus 1 to the power of 41, did they say integer? Yeah, okay, integers means positive or negative. Is odd, but 79 times by n to the power of 40 is even, and odd minus even equals to guys, odd, right? So not equals to 2. So that's already contradicted. And let's try it for if n is odd. We have n plus 1 to the power of 41 is even, but 79 times, I don't know where these random numbers came from, but as you can see, if we minus them, we have even minus odd, which is still odd. If you have an even number minus an odd number, you're going to get an odd number, which is not equal to 2. So I feel like that's it for that question. It is pretty early in the paper. I don't think there's more to it, but I wonder, like, if you guys are in the sort of education sphere, like, how would you train your students to be considering parity, like even and odd arguments, when dealing with questions like this? I mean, sure, it's easy to find when the question itself explicitly mentions even and odd, but if you don't have anything, you know, there's no scaffolding here, right? So how do you prove it? Because you're gonna have kids going, oh, binomial expansion. You're gonna have kids going, oh, induction, guys. Any induction enjoyers? But that's all wrong, because it's meant to be there exists no integer, right? So if you want to prove there is no integer, you wanna try to find. You're not trying to find a counterexample because then you're like, you know, you're trying to find that there's no example. And to prove there's no example, you have to test all the cases and exhaust it. And even and odd is probably the most natural one. So if you're watching this in the future, I don't know, I mean, give it a go, right? It is one of those things. You got to develop a sense for it. I feel like any advice, anyone who's got a suggestion on how they did this question, maybe in a different way, please, yeah, pipe up and chat. Yes, I did that too. Rashi celebrating, wonderful. Do you do contrapositive? Look, contrapositive makes this hard because it's like there is no integer. How do you write a contrapositive for a negation of a there exists? Do you know what I'm saying? Like, you're already like going, there exists, but it's sort of like the negation of a there exists. Like, we already have problems even writing that. Trying to contrapositive that is damn hard, okay? So do you have to do some math? Yeah, that's what I did, I think. So moralistically is down for that, yeah. Considering my maths teacher, he probably wouldn't, yeah, but your maths teacher might not be marking the HSC. The guys in the marking department, they actually have a look at all the papers. Could you say the magnitude must be a real number? Are we looking at, I can't remember where we're up to anymore, but, okay, well, I have to keep going, hey. It's B, 9 is B. Bro, people are still like telling me like my answers are wrong. Anyone get D for 8 lols? All right, moving on. Guys, you might want to get on track with the replay. We're up to question 12E now. All right, moving along. So, how those? Yeah, everyone's like gaslighting each other about question 9. I don't think you need a contradiction because it's just a... Yeah, Pratham, you're actually right. Like, there is no need for contradiction because in the end, if you directly tested these cases, I'm totally keen for you to just done, right? So prove by exhaustion is totally fine. Yep. Because everything except question 16 is easy. 85 is 95 plus. Yeah, bro. Okay. But wait, why is 9B? I can go back and explain that later, but I got to keep doing the exam because I'm in the middle of an exam, hey? Question E, the line blah passes through this, find the equation to the line. So we're gonna just take the vector, the direction vector, which is simply, you can take the position vector and minus them, right? Which equals 2. I'll just quickly do this. So 4, I've got to get the signs right. Hey, minus 5, 6. So therefore, you can say vector R is, you can take any of these. I'm going to pick B just because it looks easier, okay? Plus lambda 4 minus 5, 6, and that's the equation, the vector equation of the line. Okay, so that's E part 1 done. E part 2, determine giving reasons whether the point lies on the line L. Whether the point C lies on the line L. So what you're going to do is you're going to put C on the other side, 10, 5, and minus 2. 7, 0, 2 plus lambda 4 minus 5, 6. Let's just you know, try it. So 10 equals to 7 plus 4 lambda and 3 equals to 4 lambda, 3 on 4. Now, if we put this lambda back into the other guys, it's not going to work, right? So you go 5. Now, if lambda equals to 3 on 4, the point on the line is actually 10, 3 on 4. I don't want to do this. This is like 15 on 4 or something like that. 15 on 4 minus 15 on 4, and then times that by 6. You're going to get 18 on 4, like 9 on 2. That is not the point C. So you can see that no such lambda exists. And I think we're at the end of that one. So yeah, it does not lie. C does not lie. Okay, I don't know, maybe I've made an arithmetic error. This question just feels so trivial. Like, okay, so minus 5, 6, okay, and 702. I mean, I don't think I've made a mistake here. So if they want us to make this a 10, you gotta be 3 on 4. Huh. Yeah, honestly, yeah, that's it. That's about it for question 12. Question 13. How are we going for time, by the way? I think we're making good time. We spent about like 20 minutes catching up and dealing with 30 marks. So let's go on to 13 now. No spect, you're wrong. Spectacular, bro. Cis equals times cis equals 1. Bro, it's -1. Doesn't lie, you're right. Simply multiply. Man, we got a whole argument going on about question 9. Why is 9 so special? Why is no one talking about 10? Has everyone given up on 10? I've given up on 10 until later. Okay, question 13, let's go. Question 13, the point A has position vector. The line, oh man. Okay, so they give it us in component form for some reason. The line L has vector equation. Why is it weird? Why are they giving it to us like this? So we got a vector equation that's made purely from a 0, 0, 0 and a 1, 1, 2 with a t as the parameter. Weird, right? And point B lies on L. So this is line L. Point B lies on L and has the what? So we're saying apparently that P 2P is equals to some multiple. Wait, isn't that just T equals to P? Okay, whatever. T equals P. Wow. Okay, so what's the big deal? Show that AB. What? Are they asking us to just, excuse me? So we've got 8 minus 6, 5. And that's point A. And point B is P, 2P. Please don't make me find it. Oh, man. Alright. AB. Vector AB. We take the destination, which is P minus 8. P minus 6, so P plus 6, and 2P minus 5. Fantastic. So we're gonna take, oh, come on. Don't make me do this. It's like a waste of time. Magnitude of AB squared equals to x squared plus y squared plus z squared. Hey guys, free marks is free marks, right? Like if you get these marks, like Vanny 3 minimum. Okay, guaranteed. Like, we made it, guys. Schoolie's coming up. Path of Exile 2 coming up. Yo, any Path of Exile enjoyers in here, in chat? Bro, you just finished your HSC. Just imagine, you got like 4 months of continuous, non-stop Path of Exile 2. Holy. I'm gonna guess like these add up to the terms they want, so I'm just gonna write their term because I can't even be bothered to check. Brother Edwards, I want to like remove the message you put because that's like unethical. Yeah, Diesel Darling, a shout out. I don't know if I want to do that. I heard Diesel Darling is some sort of like celebrity that's not like, you know, a thing. Like it's not children friendly. We're gonna like leave that alone, Diesel Darling business for the moment. But yo, dude, what's going on, Brother Edwards? All right, so let's keep going. I've just done part 1 of that question. We're gonna get to part 2. Okay. So can I just quickly give some etiquette to our friend Amelie over here? Amelie, you cannot like post stuff that implicates who I am, because if you do, like I'm gonna ban you. Okay, so this is the ban warning. Ban warning. Identifying information equals ban, okay? Like it's just poor etiquette. But yeah, nice of you to touch base. Okay. Moving on. And all caps is pretty... What would a 20 go to? Dan says, Dan Tax. What would a 20 go to? Are you going to do something like this for 3? Yes, 3 unit definitely. 3 units more comfy, right? Everyone's going to be like chilling after 3 unit. We'll do... what was the ban warning? Oh, just a bit of doxing. Just a bit of doxing for people who are sort of aware of who I actually am and where I work. I don't think it's a good idea for this channel to have any overlap with my employment. But yeah, there you go. Anyway, hope you're all chilling at home. It's question 8 in the syllabus. Conjugate going to the exponent. Look, yeah, it's debatable, triple pi. Conjugate, it's not. But it's within the tools to do them, so I think they're going to stand on it. And they're going to like... I think you should speed up because the end of the paper is at much higher difficulty. Only question 16 is hard. Brother. Like, question 16 is hard, I know. Where am I on time? I'm about an hour in. I'm feeling cruisy. I'm like, oh crap, I'm not even halfway through 13. I'm not feeling cruisy, guys. We're not okay. We're not okay. He's right. Ragav is right. I need to speed up. Give Amelie and I a shout out. Okay, well, whoever these Lucinda and Amelie characters, we're going to give you guys a shout out. Hope you guys have a great rest of the HSC. Whatever I said will now just be permanently on this video. Congratulations, guys. Yeah, any other shout out requests? Let's move on. Question 2. We just sat there chatting for 3 minutes. It's almost like we're just chilling. Hey, it's not my HSC, it's your HSC, guys. Hence or otherwise, determine the shortest distance between the point A and the line. Oh, okay, I see what they're trying to do here. So we've got a line, and they want the shortest distance from point A and the line. Really? I'm a bit stumped already, guys. I'm getting distracted. Distracted by chat. I got cooked. Juice Pepper got cooked. Diesel is here. I love Elizabeth who says Diesel. Why is this obsession with Diesel? Who's Diesel? Actually, please don't tell us. Don't educate us on who Diesel is, please. Please don't. Shout outs to Elizabeth. Okay, so let's have a look at this situation over here. Hence or otherwise determine the shortest distance between point A and the line. What is point A? Like, it's just a coordinate. Don't tell me they want us to do Pythagoras, because that would be so boring. Oh no, oh my god. Holy crap, so they want the minimum value. Are they serious? The minimum value of AB. So they literally want you to find the axis of symmetry of this parabola. I thought it was some projection business, guys. This is ridiculous. Minus B on A, right? So 24 on 6. B on 2A. Sorry, I've forgotten my year 10, guys. I can't do year 10. Minus B on 2A. Okay, it's at 2. The minimum's at 2. So the minimum equals 6, 2 squared, minus 24 times 2 plus 125. We'll do that in our head, right? 24 minus 48, negative 24 plus 125, 101. All right, moving on. Let's do 13b. We're going to speed up. Remember, the guy said speed. He needs speed because he said 16's hard, guys. This is so insightful. Neither can I. I know you know Diesel. There's some Diesel business going on. It's more like these old guys, you know, like Diesel, get it? These old guys chatting in chat. Okay, B. A particle is moving in simple harmonic motion described by this. All right, we got x double dot equals to minus 4, x plus 1. Okay, cool. We know the basic definition of a simple harmonic is minus n squared, x minus the center. I don't know what letter they use nowadays, what's fashionable for the center, but we can get the period out of this. When the particle passes through the origin, the speed of the particle is 4. Okay, what distance does the particle travel during a full period of motion? So you know what I'll do? I'm going to quickly work out n. So n equals to 2. Okay, and when the particle passes through the origin, the speed of the particle is 4. Oh, that's low-key annoying. That is low-key annoying. I know what they wanted to do here, but it's like, do I really want to go for this? Do you guys know about, does everyone know about this? Everyone knows about this, yeah? Like this thing. So we've got quite a few things already. We've got, I don't have amplitude. which I think we're going to get by doing this. So we're going to do this, got the amplitude, we got x plus 1 happening because obviously c is equals to -1, okay? So when the particle goes through the origin, so we're going to put the origin as x, which x is 1. So x equals to 0, v equals to 4, so 16 equals to 2a squared minus, is that a squared there? I forgot the squared, guys. Minus 1, 8 is a squared minus 1. A squared equals to 9, so a equals to plus minus 3. We're going to take 3 because it's the amplitude. So what distance did it travel during the full period of its motion? So no matter where you are, like in the sort of thingy, simple harmonic motion, you're going to go that and back if you're starting from the middle, or that and that, you know, if you were like the middles here. So 4 sets of amplitude, we're going to have the full distance, d equals to 3 times 4, which equals to 12 units. Pretty chill. Okay, is this one, or this one is root 50, I think. Root 101. Did I forget to root? Oh, wow. Yes, I did. Okay, guys, minimum value of AB squared is this, so therefore minimum AB equals to root 101. Man, that's terrible. There goes another mark. Is it root 101? Yes, it is. It is. Please sing, I'm sad. No singing. No singing, guys. No singing. This is a serious exam. This is for people to watch in the future when they actually do the exam themselves. Okay. So, yeah, I got that as well. Root 101. Root 101, my bad. Because we have the magnitude square. Thank you, Banana, for that. Excuse me, sir. What, sir? Extension 2 maths teacher. Bro, I'm not an aspiring extension 2 maths teacher. I'm just like, do I even do it? I just teach advanced maths. I'm here for my own entertainment. Okay? Bro ain't state ranking. What? That's terrible, bro. Maybe JS lock in little, bro. Maybe JS. What's JS? XLR 3083 Lite. That sounds like an edgy YouTube name, bro. N to the squared of 2 is 4. Is it? Okay, guys. All right. I need to concentrate. I can't even square a 2. Thanks, everyone. 2, 4, 4. But the answer was so nice before, guys. All right. That never happened, guys. It never happened. What we actually have is 4 sets of root 5 equals to 4 root 5. My bad. Wow. Okay, can I go back to concentrating? I need to do 13C. How are we going for time? We're about an hour and 10 minutes in. Kind of worried now. 13C, the particle of unit mass moves horizontally in a straight line, experiences a resistive force, blah, 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 blah. Okay, to the right. Okay, so x double dot equals to minus k v squared. It wants the velocity function. So look, I'm keen on like separating the variables and stuff, and I'm sort of getting the vibe that we're gonna do a v dv dx for this one. No, yes, we are. Okay, v dv dx equals to minus kv squared. Separating the variables. Minus k dx. Divide the v squared over to the outside. 1 on v dv. Integrate both sides. We got ln v equals to minus kx plus c. Okay, and we know that after the particle has removed 15 meters to the right, so we know initially it's at the origin, and so when x equals to 0, v equals to 40. Okay, so ln 40 equals to c. I'm gonna chuck all this back in. So ln v equals to minus kx. What's k? Oh, they don't have it yet. Plus ln 40 kx. No, they stick to minus kx. So we're going to keep minus kx on this side. Equals to ln v over 40. So v over 40 equals to e to the minus kx. And because v is positive, we don't really have a problem to take the absolute value out. Okay, because I don't think it's changed directions yet. So I'm just gonna like fluff it. I'm not sure if there's any nuance that makes me lose a mark here, but I'm happy to take the show. So part 1. Part 2, show that k equals this. So they gave us some further information. After the particle has moved 15 meters to the right, its velocity is 10. So when x equals to 15, v equals to 10. So we have 10 equals to 40 e to the minus k times by 15. We got a quarter equals to e to the minus k times 15. Ln a quarter equals to minus k times 15. So k equals to ln a quarter over negative 15, which actually means that k equals to ln because there's a negative sign, so we go take it out, negative ln 4 on 15. Yep. Okay, cool. That's good. And part 3. At what time will the particle be... what? Oh no, don't make us do this. V equals, now we got 40 e to the ln 4 over 15 x dx dt. Really? I don't want to do this though. Does anyone else want to do this? Pretty hard just looking through it. Hard. Sheesh. Thoughts on the 2-unit paper? Yeah. 2 units actually like low-key hard. I checked, I actually checked the, what's it called? I actually checked Bingo, the last few questions of the advanced paper, and they looked hard. Amelie wants to show us how to do this integration. You know, low-key, like, yeah, I think, you know, you can actually do this if you're an advanced student. Okay, we're going to flip it. So we got 1 on 40, e to the ln 4 on 15 x. Going to integrate t. So we found t. Integrate this with respect to x. 1 on 40, we're going to divide by the ln 4, so 15 on ln 4. I don't know, I feel like these things I make mistakes doing as well. Okay, so we integrated this plus c. At initially, when t equals 0, x equals what? Is at the origin. All right, cool. X equals 0. So that's good. So that means 0 equals to 1 on 40, 15 on ln 4, plus c. C equals to negative 1 on 40. I have not bothered simplifying this yet. I don't know why. Okay, so let's go back and get the t formula again. So t equals to 1 on 40, 15 on ln 4. I'm sure I'm taking too long doing this. ln 4 on 15 minus 1 on 40 times 15 on ln 4. You know what I got to do though, right? Is velocity is 30. I'm going to chuck velocity into the other one. So 30 equals to 40 e to the minus, I should have left it as k, huh? What is k again? ln 4 on 15. Oh, man. And we're going to call this x1. I'm just going to chuck this in now. Where's the x gone? Guys, where did x go? Is it here? Yeah, it's here. Okay, so we know this, right? Like, we know that 30 on 40 equals to this thing. So if we plug that in here, where the minus sign, how did the minus sign disappear again? Oh, I know, because of the thing. So e to the blah is this thing. If we flip it over, 4 on 3 equals to e to the other thing, right? E to the ln 4. This is very scuffed arithmetic. If I was actually in an exam, I'd do this very carefully. Okay, so this bit would have now turned into 4 on 3. So we've got 1 on 40, 15 on ln 4, times 4 on 3, minus 1 on 40, 15. It's amazing how this guy has managed to do this entire question without simplifying these fractions. So we got 60 on 120, so 1 on 2 ln 4, and minus, we've got a 15 on 40, so that's going to be a 3 on 8 ln 4. That's a 1 on ln 4 factorized out of a half minus 3/8, which is actually going to be 1/8. So 1 on 8 ln 4, that's an awful answer. Like, I don't even know it's right, guys. It's terrible. Howard Chen locking king? Bro, people are bullying. People are bullying apparently, and I need to like dox. Need to get rid of doxes. It's over. No need to improve. Whoever you are. Hey, this is a safe space for fellow extension math students trying to improve. 104 people are watching. Sheesh. Yeah, I gotta like start moderating these comments because you know, there are like spammers in here. There's like heaps of like spammers, and we need to like start deleting stuff that can like identify. You need to lock in, bro. Really? Thanks for sharing. 13D. I don't know how I'm gonna go at this rate. We're gonna speed up on the questions that we can actually do. So x plus y greater than or equals to 2 root xy. Okay, show that a, b, c are positive real numbers. We've seen this before, I feel like. You know, guys, like whenever you see this kind of stuff, 1 on a plus 1 on b plus 1 on c equals to 1, right? Then this. Okay. Oh, this takes a bit of thinking. I'm low key. I'm sort of just gonna write out a few of these things first. So we got a plus b. I'm just like suspicious about where this ABC comes from. That looks a little bit scary actually. I'm gonna like just, you know what? Okay guys, let me tell you guys, let me let you get in on a secret about these kinds of questions. When you have an inequality that currently looks too hard, what do? You don't start crying, okay? The question 13 is 16 marks, guys, 16 marks. Retire please is crazy. Dan Tax, retire please. Oh man, we've got trolls on the, will you put screenshots of your solution on BOS later? Yeah, TyWeb, I'm gonna try my best. I'm not sure what the accuracy like. I feel like today I've had to like do a bit of moderating of chat a bit more often. So the interaction's causing the accuracy to go down. There's probably like a slew of numerical errors. What I might do, TyWeb, is later on, I'm gonna like just look into the more interesting questions of this paper and write them up properly, like the actual interesting ones. But I will like send through this file. Okay, so yeah. Now back to this question. My advice, everyone, is just take some equivalent statements, divide everything through by sort of ABC. So you got like a little one situation, because this will really help you, because you're gonna get this thing now, right? So instead of like looking at this going, what? You have this, and then you can be like, doable. We can do this. How do we do this? Well, let's have that as our target. Okay, we're gonna try to aim for proving this statement. How do we prove this? We do know that 1 on A plus 1 on B plus 1 on C equals to 1. So I'm sort of like still not sure where the AMGM actually came in. So what we're gonna do is we're gonna just look at this, guys. Check this out. This thing comes from this. You're gonna take the AMGM of this and this. Actually, not even guys. Just 1 on B and 1 on C. So if you just wrote the AMGM, but just in like the normal expected order, it'll be 2 root xy, so 2 root 1 on BC, which equals to, equals to 2 over root BC. Okay, there is our 2 root BC, and we pretty much have everything we need really, because if we wrote all the other guys out, so we got 1 on A plus 1 on C greater than or equals to 2 on root AC, and 1 on A plus 1 on B greater than or equals to 2 on root AB. Okay, add them all together, we've got 2 sets of 1 on A plus 1 on B plus 1 on C, right, is greater than or equals to 2 sets of 1 on root BC plus 1 on root AC plus 1 on root AB. Okay, and what did we say that was? 1. So this was 1, the 2's cancel out, therefore we got this conclusion from our algebra, right? Very standard once you sort of see the secret to this, okay? And once you have this, you know that the next line, you're gonna look back on what we did earlier and go, hey, this thing, that's just, how do we go from here to here? We divided both sides by A plus ABC. So how do we go this back to that line? We times both sides by ABC. So that's all we have to do. We're going to times both sides by ABC. And and we have the result that they're asking for, which is therefore, right, better given the result, because like the markers actually want to see a proper proof, so they don't want you to write equivalent statements throughout. They might not be happy with that. So you times everything through by ABC, you're going to get the exact result you want. So at this point, you might as well just copy it out. BC plus B root AC plus C root AB, and that's going to be the answer to D. So we're on question 13, but we're like, how far are we? An hour and 25. This is not good, guys. We need all the time we can get for the later questions. Question 14. Prove that if A is any odd integer, okay, this is a freebie, okay, so A is odd. So we'll do a direct proof for first. We'll say if A is odd, we have the idea that let A equals to 2m plus 1, where m is a member of the integers. Okay, so a squared minus 1 equals to 2m squared plus 1 squared. Take away 8. No, why am I taking away 8? I'm taking away 1. Minus 1 equals to 4m squared plus 4m minus 1, or plus 1 minus 1, which equals to 4m bracket m plus 1. So what this tells you, again, this is a second time where we have to use the sort of an even odd argument, okay? So you say if m is even, look, you can actually waffle a bit here and say one of these two, at least one of these two will have an extra factor of 2, therefore by the fundamental theorem of arithmetic there's an 8 in there. But let's just play it safe. We're going to go m is even, let m equals to 2p, so we got 4 times 2p times 2p plus 1, which equals to 8. We'll call it k or something, where k is a member of the integers. That's easy. If m is odd, then you're going to have 4 times 2p plus 1 times by 2p plus 2, which equals to another 8 of 2p plus 1 times by p plus 1. And here, yeah, so again, another 8k. So therefore, a squared minus 1 divisible by 8. Yeah, honestly, like if you want to waffle, I don't know, like maybe TyWeb can weigh in here. If you want to waffle that this is divisible by 8 because at least one of these will have a factor of 2, how much do you have to say, right? I wonder. What do you guys think? Did you guys just like finesse it here and just waffle and say, hey, it's got a 2 in there? I don't know. You guys let me know. So that was question 14A. 14B. Okay, how does internal ranking affect your I think I only answered 30 marks. Can I still band 6? Probably not. I'm sorry to say. Joshua Bigland on Skibbity. I'm going to pretend I don't know what that is. Moving on. Chairman. Yeah, internal ranking. Look, internal ranking does affect it because based on how your school does, the better your internal ranking, the better your assessment mark is going to be in the HSC. So your mark will be the scaled mark or wherever sort of roughly that person in the exam, the person that did similar to your internal ranking in the HSC exam will be your assessment mark. It's a very rough sort of explanation, but that's the best I can do for you right now. Just said that 8 is divisible 4 and both divisible by 2. Look, I don't know. I feel like you can't really approach it from an 8 angle. You can't start from 8. You do need to actually mention something about this expression. Maybe, look, honestly, I didn't look into the contrapositive, but I think the contrapositive is harder because establishing that a squared minus 1 is divisible by 8 is actually, it's doable. I think contrapositive works, but it's going to take like some more like argument afterwards, probably along the lines of like if you got a squared equals to 8m plus 1, you're going to have to like talk about how this cannot be even. It better be odd, right? Come on, look at this, right? So if you say, well, if a squared is odd, then a is odd, kind of thing. I feel like you're going to need 2 contrapositives to prove this with a contrapositive starting from 8. So I'm not sure. Yeah, look, Sandy, that works. Thank you. 1 plus 1 equals 4, question mark. I'm not sure about that. I don't think I did that. Yeah. Surely 2 consecutive numbers is valid. Yeah, Chair, I reckon they'll take it. I think the mark is going to be pretty generous. If you say 2 consecutive numbers, one of them has to be even. If you just wrote that as a sentence, you'll be fine. Okay. 14B. Use mathematical induction to prove this. So we're going to prove P1 for, P5. Okay, P5. So left-hand side equals to 10C5. I'm going to not pretend I know what 10C5 is. 252. Right-hand side equals to 2. It's actually pretty close. Wow. So 2 times 5 minus 2 equals to 2 to the power of 8, which is 256. Therefore, left-hand side is strictly less than right-hand side. All right, P1 is true. Sorry, P5 is true. We want to prove that P of K implies P of K plus 1. I'm sure it's all integers. Yep, no skipping terms here. So we're going to assume... Oh, this is sus. Like, I know where they're going with this one, and this is not happy. Yeah, okay. So I'm going to say assume this is true. And we're going to say required to prove that for n equals to k plus 1, that 2 to the... Hey, at least it's not a series, right? We're not getting any sneaky extra terms here. Plus 1 is less than 2 to the 2 bracket k plus... We're going to like tidy this up. This looks messy already. Minus 2, i.e. maybe it's better to say 2... okay, oh man. I don't know about this actually. This is scary. Guys, this is scary. Like I'm getting like algebra vibes from this one. So I'm going to go, yeah, okay. So this is the RTP right now. Okay, our goal is to find a way to sub in the assumption, which means we need to expand this, unfortunately. So 2k plus 2 factorial over k plus 1 factorial and another k plus 1 factorial. Really? 2k minus, yeah, k plus 1 factorial. Okay, now, to turn this into the assumption, we are going to unroll this so that we got rid of all the extraneous factors. So this is a 2k factorial on the top, and down below we have a k plus 1 squared. And we're just going to write this as separate because I think there's some nice cancellation going on here with a k factorial down below. And that's going to... So we're talking left-hand side right now, obviously. And here this thing cancels out to a 2. So there's a 2 there. And we have 2 bracket 2 to the k, 2k plus 1, sorry, over k plus 1. Multiplied by... Now, because we are writing this as a... we're still simplifying. So this is 2k ck. And we know from the assumption that this is smaller than... It's not that bad, eh? This is actually not that bad. There's no... I don't feel like... I know it's an inequality, but there's no like recurrence relations. There's no like, you know, weird stuff like this in this exam. So I'm just checking what's up here. It's 2k minus 2. Yeah, with a 2 at the top. Okay, let me just check how this is going. Our goal is, can we get it to be less than the other side, which is 2 to the 2k. Let's break this up a little bit. So I'm gonna keep saying equals for now. 2k plus 1 over k plus 1. Here we got 2 to the 2k over 4, right? So we've got an over 4 happening here. We divide it through, so we got this, and this looks beautiful, right? So we got a 2 on the bottom, 2k plus 2. Look, this is clearly less than 1, so we can clearly say that this is less than 1 times 2 to the 2k, since you know, when you got a number on the top that's smaller than the number on the bottom, even if slightly, this is less than 1. So yay! Therefore, true by mathematical induction. At this stage, you're not going to care like how much setting out you write for this. So, question 14c. The induction didn't do too badly. You must state by assumption when you use your assumption. Brother, do you really think in a HSC exam they like if they can see you know what you're doing? But look, okay, I'm being toxic. Guys, everyone, guys, you called me out. Yes. Where do I write? By assumption. You're right. This is what I preach, and this is what I should do. Appreciate it. Cool, Berman. Thank God, Bob. Bob Marley, 10 was 10. D was 10. I still can't do 10, by the way, guys. Holy. All right, well, I hope he's right, okay? On Skibbity, On Skibidi, here's my sigma alpha. That sounds kind of dodgy, to be honest. I'm pretty sure that's some sort of like rap song. Just plug into the calculator. Yeah, 14c. Let's go 14c. Argument of z over w is equals to minus pi on 2. What do they want for this? I don't like these questions because it's a little bit like unscaffolded, right? And they want the value of z minus w on z plus w. So firstly, I'm going to just take the a diagram approach to this. So the argument of z minus the argument of w equals to minus pi on 2. So it seems to me that you've got a z. Okay, let's say this is z. And you want to say that the difference between these is 90 degrees. So that 90 degrees, so w has 90 degrees more than z. I'm going to put w over here because this is the only way that this diagram can be actually drawn. The length of w could be a bit longer, but we don't really mind, okay? So we got a 90-degree situation. Z minus w is the vector connecting the relative vector from z to w. I hate when they like make my line straight like this. So that's z minus w. Z plus w is the parallelogram, the length z plus w, okay? So I'm sort of like wondering if this is helpful. Find the but like they want the modulus. Like, how is that a thing? I'm kind of annoyed now. I have a feeling that I know what they want, but I'm not happy about it. Okay, there's no elegant geometry way of doing this because you still need to find the division of these two, and the angle between these, depending on the length like of w and z, are quite undefined. So we can't really get a relationship between z minus w and z plus w. The only thing we can really say is probably along these lines. We can say that w equals iz, but with an extra scalar multiple because we don't actually know how much it is. So I'm gonna go with this, okay, and let's try it. So z minus w on z plus w equals to z. This is getting to a point where like I think people are not going to be able to like figure out these themselves. Krz. Okay, here we go. This is a little bit scuffed as well. I'm worried about this k business because we don't know like w's any length in relation to z. So let's hope this works out, huh? Got modulus of z 1 minus ki. Okay, the z's will cancel out luckily. We're gonna try going for the oh yeah. Oh, okay, yeah. No. Everyone, guys. Whoa. Well, any one enjoys in chat when like everything cancels out? That's crazy, guys. I didn't expect this to be a 1, but it is. So I'll take it. D. Guys, you just integrated 4 times for 16C. Yeah, I haven't done 16C yet. Jamal Shush, put question 1 as B. Brother, I thought question 1's D. Is it just 1, Mr. Teacher? Sheesh. Brother. It's just 1. On my life, it's 1. Joshua Bigland. Yeah, amazing, guys. The answer is 1. Divide everything by W. Look, honestly, I came up with my own cooked way of doing this, but it is 1. I know there maybe is a nice way of doing it. Oh yeah, of course. Like you could have divided everything by W and saying that W over Z is some multiple of I. Yeah, for sure. Okay, good job, guys. Yeah, easy. All right, let's move on. D. I don't know why I went this whole like geometry because I love geometry. You see, like I like to talk about it in geometry. But yeah, I'm glad I got 1 as well. Thanks, guys. Yeah, D. The following argument attempts to prove. Now we're gonna like switch the other view here so you can see what's going on the paper. Okay, so here we go. Attempts to prove that 0 equals 1. Isn't 0 equals 1, guys? Like we all know that, right? Like surely no one thinks 0 is not 1. Low key question 1, not B, bro, on everyone's soul. Okay. we're going to integrate by the method of integration by parts. Okay. All right. All right. I mean, sure, if you want. Yeah. Yeah. Oh. Yeah. Guys. Yeah. I mean, guys, I don't agree with this at all, bro. This is 1. 0 is 1. This is amazing, guys. Oh, man. This is changing my life. Does this change anyone else's life? Like, who thought this was funny? Like, even if they didn't know how to get the 2 marks, who thought this was clever? This is damn good. I'm looking at this going, damn, okay. Okay, so why can't we do that? Where is it wrong? Yeah. I'm just gonna check something. So we're gonna say VU dash. Or do they do UV dash? What's fashionable these days? I can't even remember. What's wrong with this? Something's a bit sus about this part. I'm just like scared. What's going on here? Guys, I'm so convinced. I'm 100% convinced that it's 1. Howard, at least you didn't write a creative to 2. Should we teach him the Harry Mack way? No, brother, I don't see it. Okay, look, yeah, look, someone said the constant. Look, I know the constant is a thing, but you would assume that this has a constant contained in it. So why is it that the constant of this differs from the constant of that? Like the integral is identical. If we took the integral out, okay, so what we can do is I'm gonna look, obviously we had a little bit of backseating and I love it, guys. I think it's 1. I think 0 is 1. Like, we've proven 0 is 1. But thanks to one of our audience members, I actually think that what is wrong with this argument is this. If you, I wanna like wing it and say something like this, okay? We preserve the structure of the integral sign by moving the other integral to the same side, and we get this. Everyone happy with that argument? I feel like that's the best I can do on this situation. I know that you can like write a whole like yap, right? You can yap a whole essay about how like integrals should have constants of integration, but so can that. So these integration constants are arbitrary, and then you can yap a little bit about arbitrary constants and be like, these constants don't necessarily have to both be the same, but saying that, they look very identical, so I'm not even buying that. But I'm going to leave that as my proof, okay? Yes, it has to be a definite integral, which will make it... Yeah, but does it have to be a definite integral, though? Like, you know what I'm saying? Like, yeah, I'm with moralistically. I think this looks clean. This looks very convincing that it's going to break down. And that's it. That's the best I can do for this one. Yeah. I think if I was a student sitting this, I would have yapped. Like, honestly, I would have yapped about how integrals have a constant of arbitrary constant of integration. So these constants have like C1 and C2, and like they just don't necessarily have to match, and therefore it's not a solid argument. But I don't know if that's going to be like the marking criteria. Actually, I'm curious on what Nessa is going to ask about for the marking criteria. Like, what can they accept for this question? Actually, I feel sorry for the person who has to mark this. Moving on, 14E. Does anyone else feel sorry for the people who have to mark this question? 14E, how are we going for time? Not good. The diagram shows triangle OQA. I honestly, personally hate these questions, but I'm going to go back to my... Oh, no one can actually see my thing. Hey guys, back to this. So I'm just going to leave it on the screen for a little bit here. This is my proof. I'm wondering what Ness is going to offer as the marking scheme for this. Okay? So I'll just give you guys a few seconds to look at it. Yeah. C is not necessarily 1 because the integration of 0 is an arbitrary constant. That's my best guess at this question. 14E, triangle OQA. All right, let's have a look at what goes on here. Point P, I hate these ratio ones, but they're very doable. So what we're gonna have is I'd rather not copy the diagram out, but I think I should. This is one of those centroid style questions, which I think are like nice. Okay, they're very doable. This is probably like their effort to take the intersection of the median and change the ratios a little bit so that point T is chosen, so that OR and T is collinear. Okay, so T is sort of unknown, right? We do know a few other things. We're gonna say OA is vector A, and OB. I'm gonna just change the color scheme for this actually. OA is vector A. OB, they decided to choose OB as vector B for some reason. I'm not that keen on that. And PR is a multiple of PQ. Okay, so I think they know that they're gonna be like K something. Okay, there's something going on here. Let's have a look at P. So P lies on OA, so that OP to OA is in the ratio 3 to 5, and OB to OQ is in the ratio 1 to 3. I just don't know why they chose OB like this. It's awkward, right? You'd think that they would just do like all the way across, but maybe because AOB is the actual triangle that they started with. Okay, so let's do part 1. Show that OR equals this. So this is just a matter of head to tail addition. We're basically going to get OP. Now, guys, with interval division, okay, they made it really nice. They didn't even say OP divides OA in the ratio this. They didn't use like division. You can just literally go like this. You can go OP over OA equals to 3 over 5. You can do magnitude notation if you want, right? And that means the scalar multiple that we're going to use is 3 on 5. So vector OP is 3/5 of vector A. Now let's go over here and have a look if that's all we need. We're also going to need the K stuff as well. Okay, so let's get PQ as well. So PQ is going to be, rather not, OQ, take away OP, and OQ, again, using the thing is OB to OQ. So I'm going to quickly do this again, just as a ratio, because I'm sort of like worried about this ratio notation, right? Equals to 1 over 3. So OB is 1/3 of OQ. Therefore, OQ, the scalar multiple, is 3 times OB. I mean, you can tell, like, this is 3 times, while this is 3, like, you can tell this is 3 times OB, and this is, well, 3/5 of OA. Yeah, so I think my fractions are solid right now, and I'm going to go OQ is 3 vector B minus OP, which is 3/5 vector A. Okay, great. We've got PQ going on, and they told us that PR is the ratio, is the scalar multiple. So we're going to times that by K right now. So 3K vector B minus 3/5 K vector A. Easy. Okay, now we're going to have OP. So OR equals the sum of OP plus PR. Like, I'm pretty sure it simplifies to exactly what we needed to. So I think they kept 3KB alone, and we have a factorization of the A. So I'll just write both terms first. So we got 3/5 A minus 3/5 K times vector A, and which is what they wanted, right? 3KB plus 3 on 5 vector A bracket 1 minus K as required. Okay, now they're going to go writing AR as H of AB. Okay, so in part 2 they decided to like kind of give you some guidance, and we're going to write AR as equals to H of vector AB. And what's our goal here? Where H is a real number, yeah, it can be shown that OR equals to 1 minus H A plus H B. Oh no, I know where this is going. OR. Yeah, okay. Okay. So, like, guys, I mean, this question's kind of nice. They gave you this, and they gave you this. So they gave you OR twice, right? Show that K is this. So I feel like you can just literally say that they're equal. I mean, we're going to make them equal. Now, I don't know whether you guys have a grievance against these style of questions. We're going to match the coefficient of vector A. But the trouble is that you have to almost have some sort of university first year knowledge about how A and B, because they are not like collinear, that they form a basis for the plane, which means that the only reason we can match coordinates, like we can match the coefficients of A and B like that, is because A and B are what they form a basis of a plane. So 1 minus h is going to be equals to 3/5 of 1 minus k, and h, so the coefficient of B, vector B, is going to be h 3k. So subbing it in, 1 minus 3k equals to 3 on 5, 1 minus k, multiplying it across, 5 minus 15k equals to 3 minus 3k. I probably got the numbers wrong, hey. Look, no, I got it, guys. It's 12k, k equals to a sixth. Honestly, I don't know about the challenge of this question. Like, they've literally given you both things to solve. So even if you have no clue how to find all the addition of the vectors and keep the ratios under control, you can get those 2 marks easy. Okay, so part 3. Let's keep going. Plus 100 stench aura. Equation is such a stretch. Equating is such a stretch. Yes, I am shaking. Look, honestly, like, guys. Do you guys believe equating coefficients is just a bit sort of a long bow to draw when it comes to vectors? But it seems like everyone does it, so everyone just keeps going to do it. Find OT in terms of A and B. So now that we got k equals to 1/6, everything comes out, right? So if we're going to get OT, here's what's going to happen. K is 1/6. What was k again? What was the whole point? Right. I low-key think this part does take a bit of effort to get. Let me just think about it for a second. So now we're interested in this line, and we've just got this, but how are we going to get the whole thing if we don't know? What do we actually get? We got AR and RB, and we got this ratio, but we don't know the last ratio. How do we get to OT? Can we like, oh, don't tell, no, please. Oh, no. Are you telling? I don't want to do this, guys, like, clearly we can either find this one or that one. We're going to have to pick one of these guys to find. I'm sort of, which one's better? Oh, man. I'm not keen at all on doing this. I know like what it takes to do these questions, but I'm just not keen. Like, we got K, we can even get H, right? Let's just write H out. Maybe they'll give me pity marks for that. Okay, 1/6, so H equals to 3 on 6, which is a half. Okay, I'm liking the half. I like the half. So these guys are equal. Yeah. Okay. How are we gonna get to K? How are we going to get this section? Like, I got this, I got, like, I could get this if I wanted, I got this, I got like everything except, oh, I got this, guys, I got this. Yeah. Still don't want to do it. No one wants to do this. No one wants to do this, but I'll do it anyway. Like, it's so boring. Okay, so what we have is they told us that AR equals to HAB because the question said so. Okay, so we're going to have H is a half times vector AB, and vector AB is obviously, we know what this is. This is B minus A. Okay, vector B minus vector A. So we got that, right? So we've got AR, we're ready to label that in. This vector is a half B minus A. because they were so kind to give us the value of h. So we got that, and therefore, what is that? Is that what we need? Actually, is that what we need? What is this good for? We still don't have any of the other stuff. Oh, gosh. There is something more to this. Let me just read the question one more time. Find OT. I'm missing something, guys. And I'm like not happy about it. I want to go back to 14E part 3 just because like I'm sort of concerned about time. So, yes. Great. Let's just start on 15. What do we got? We got about an hour. An hour and 15 minutes. It seemed easy, but it's not. Lanquins, yeah. Brother, I think you're right. The final answer to this question is a quarter A plus B. I think you're right, Asher Conroy. Like, we know that this is just some stupid, like, very similar to the medium proof, but I don't want to deal with it right now. I want to just do something easy. Let's do something easy. Let's do 15, okay? Honestly, this is starting to get worse than, like, last year's paper. Question 15. Why is my pen in red as well? Oh, man. Question 15. Okay. Consider the three vectors where O is the origin are all different from each other in origin. Yeah, okay. Okay, great. The point M is the point such that... I mean, is this 2D again? Like, what are they on about? Like, I'm just going to draw these 3 points because I don't really know if there's anything special going on here about these. So I'm just going to put them in, and M is the midpoint such that OM, okay, so A plus B, you have to show this? Oh man, okay, so we have parallelogram addition, so we got A plus B, yeah. And what we have is I think the best thing is to just draw a diagram. We got vector A, we got vector B, we got the parallelogram addition. We know that that A plus B is the diagonal. Therefore, half A plus B is the intersection of the diagonals because diagonals bisect each other in the parallelogram. I'm pretty sure, like, I just don't want to do the algebra way. Parallelogram, and therefore the point M lies on AB. Yep. I'm just scuffing it right now. I don't even care, like, at this point. Of course this is a half A plus B. Like, I think if you really wanted to do it properly, you would have to, like, yeah, what? How would you do this? Like, it's just 1 mark. Like, is there some, like, magic algebra that you have to carry out? Because you know that M is the midpoint of AB. Like, what's there to argue? Weird. Okay, moving along. B. No, part 2. Getting eager there, thinking we got to B. Part 2, the point G is the point such that it's 1/3 of... Oh, no, don't tell me. Do not tell me another one of these. There's like 2 of these. The earlier one is just as bad. Okay, so A plus B plus C equals to OG. Show that G lies on the line passing through M and C and lies between M and C. My head hurts. G lies on the line passing through M and C and lies between M and C. Great. So what we do here is we're gonna just put G down as the as what they said it was. Okay, G. But I'm just gonna intentionally not say it is. Okay, and what we're gonna do is just do this. You're gonna get like MG, and we're gonna take vector MG, which is gonna be OG minus OM, and we have all these things, right? OG here is 1/3, so we got 1/3 A, B, C minus OM, which is a half A plus B. Okay, so 1/3 minus, okay, well, come on. The 2/6 minus 3/6 minus 1/6 minus 1/6 of B plus 1/3 of C. Amazing. Okay, so we got these guys. This is MG. And we're going to talk about maybe GC, I think. Let's do GC. I think GC is a good one. No, let's do CG. No, GC, because we want positive values, okay? GC equals to OC minus OG, which equals to C minus all these guys, 1/3 A and B and C. All right, okay. So we got minus 1/3 A minus 1/3 B plus 2/3 C. And obviously, if we factorize these two guys out a little bit, we can factorize out, in my opinion, like 1/6 out of this one, like maybe negative a sixth. Nah, let's just do a sixth. Minus A minus B plus C, 2C. And this one is we factorize out minus a third, just a third. Minus A minus B plus 2C. Therefore, you say that like GC is twice of MG. Therefore, GC is a scalar multiple, so you can say GC is parallel to MG, but they share the point G, so G, M, and C are collinear. The thing is, we also wanted to prove something else. We wanted to say lies between M and C. So you can say that here, GC and MG are in the same direction, right? So in any situation, this is M, this is G, this is C. So G is between M and C. I don't know, like it's taken us a lot of work to actually even prove this, and it's only 2 marks. Surely, are they gonna like be nitpicky about this last section to get the full proof? I don't know. Okay, anyway, part 3. The complex numbers. On God, he's not being Sigma right now. Sandy, get a life. Don't know about this. With 5 marks, 5% of the paper. 5 marks total. Yeah, it's a lot of work for 5 marks, to be honest. The complex numbers are all different and all have moduli 1. Okay, using part 2 or otherwise, show that is never a cube root. Oh God, what is this? All right, okay. So what did we even learn? What did we learn in part 2? We learned that 1/3 of these guys is some point between M and C. Honestly, like, is this not the median of like the triangle ABC, right? So what we're gonna do is we're gonna actually take a complex number drawing of this, okay, where we're gonna have 3 lines. I want to be generous and put one over here, 1, put one over here, 1, and put one over here, Z, that one, okay? This looks bad. I don't like it there. Maybe I'll put it here. Honestly, I could have just used the original diagram. So what do we say? We say that A and B, okay, A and B, we got the point M, and we know that between this and C, okay, is okay. So this line, where is this line? We know that this line has a particular ratio because we found that GC equals to 2mg, so that GC is actually twice the length of mg. Let me just find that. So this is M, this is C, and GC is twice the length. The G is here with a ratio of 2 to 1. I don't know if that's like relevant to this question. Show that is never a cube root of x, w, z. If I multiply the 3 complex numbers x, w, z together, I'll have is never a cube root. Let me just think about this triangle for a second. What is it that makes it even anything to do with cube roots? G is the median of this triangle. Like G is literally the centroid, guys. Like, I mean, they use even G, right? Like we know what this is about. Like if you've done any sort of like Olympiad maths, G is the centroid, okay? And what's it got to do with anything about the cube root of x, y, z? Cube root. Why? Why is it and why is it not? I just don't like how it's all centered at the origin. So what I'm going to do is, let's see what happens if we multiply these together. If we multiply these together, I'm sort of like, I'm starting to get the realization that for it to be, right, for G to be a cube root, its modulus must be 1. On my current diagram, I'm low-key sort of thinking the modulus can never be 1, okay? Just because it's just can't get far enough. It just can't get far enough. Let's try drawing a couple of other scenarios. Maybe it'll give me some hints on what's actually going on here. Okay, so we got 1 going this way. Let's say we draw a more conservative one, like going outwards, kind of like this. And they're all 1s. And you got a triangle. And the centroid of this triangle is this. Yeah, well, that's not 1, is it? Like, I think I'm going to like just yap a bit, okay? I'm going to say that G lies inside the triangle that is A, B, and C, and therefore the magnitude of OG cannot be 1 because it's always smaller. That's like, look guys, this is a long shot. I don't know, did anyone have any better success on 15A part 3? Because this is all I can come up with after staring at it for a while. This is a pretty cooked question. Yeah, G is in triangle ABC, brother. I know this, right? Cool, Berman, you're right. But I can also tell you that G is not only inside, but it's also the centroid. Okay, so I think lying inside is the key to this question, and I do think that I'm on the right thing. I just don't know how many examples of triangles we need to draw, because it's clear that, think about it this way. I think the most convincing diagram I can draw for them is this. You draw a unit circle, okay, and you say, if I take any 3 points on this unit circle and G's got to be inside of these 3 points, it's not going to be on the unit circle, is it, guys? So I think we're good. I think we're solid for 15A part 3. This is the solution. It takes a bit of reasoning. That's not an easy question. That's disgusting. Okay, no, we got it. We got it. Okay, cube root is C. I love it, Cool Berman. I think Cool Berman is on the same page as me, and I think we got the solution for this. This is not a joke question. This is actually not an easy question. I'm surprised that they went for a centroid style, because the previous question is a centroid question in a way as well, except with nasty ratios, which I still haven't been able to do. So 14E part 3, I'm screwed. Okay, so 15 part B. Let's do a good old reduction formula just to relax. 0A x n plus a half. Oh, half, really? Dx, where n is greater than or equals to 0. Show this. Yeah, of course. I wonder what integration by parts we're gonna do. I'm just gonna write for you guys what my vibe around this question is. I'm getting this vibe. Root. But I'm also like getting something else. I'm sort of, there's something dodgy about this. Like, I'm sort of, yeah. I actually don't want to be doing this. So whenever you're faced with a situation where you've got like some situation like this, just go for the easiest integration by parts as your first effort. Okay. So we're gonna take the integration by parts of this. I'm just gonna quickly integrate this in my head. So we got x n plus a half. We got this guy. So we add 1 to the power divided by -1 divided by the new power. So 2/3 a minus x. I don't like the look of it, to be honest. We got a minus sign as well. We've got a 0 to 1. Let's just make sure I've integrated that correctly. Yep. 0 to a. Oh, excuse me. Okay, that's 0. Not a problem. Minus, we have the thing that we just integrated, so we've got a plus sign now. A minus x, 3 on 2. We're also going to differentiate this. So this is going to be n plus, not liking the look of this n, okay? N plus a half, x to the power of n minus a half, dx. Oof, oof. Oh boy. Oh boy. How is this related to the one before? 0 to a? Honestly, quite a lot, really. Because if you look at this, right, I'm going to just write this in index form for you guys. You can see that the, apart from the 2/3 having some issues, we have the a minus x by itself, as well as a root a minus x. And in fact, we do like having the root a minus x because that's in part of the in, okay? And over here, we also have I'm going to chuck the n plus a half out the front as well, followed by x to the n minus a half. Now what I'm going to do is, I know x to the minus a half is not what I really want, because what I really want, okay, but let me just check. in minus 1. If I chuck an n minus 1, it is, look, this is in minus 1. This is fine. In fact, this is fine. I'm just a bit worried about this, this part. This part. It's easy, guys. This is the easy question. We're going to split it, right? And we'll see everything already. I told you we get to do these ones to relax. Minus, put a bracket here. Okay, let me just check that we've got all the items. We got the x. This x will go into that, which creates the in again. Okay, cool. And this has an a. So what we have here is 2/3, n plus a half, giant bracket, a, right, there's an a there, of in minus 1 plus a in. Yes. Yes. Equals in. Okay, so we can make it, we're going to times it by 2, so 2n plus 1 on 3 times by another a of in minus 1 plus 2n plus 1 without an a on 3 of in. I'm going to drag this this guy to the other side, so we have in bracket 1 minus 2n plus 1 on 3. I'm not sure like if we have everything that they have. Yeah, I think we do. We have everything they have. They got an a as well on the right hand side. Thank God. I think we can times everything by 3. So in equals to 3 minus 2n minus 1. Oh, they got another 2 there somewhere. Where did they get the 2 from? What? Are you telling me Oh, guys. Did I not know how to differentiate? Where's my 2 gone? Where's my 2? Huh? Oh, don't tell me I lost the 2. Oh, man. I've got the right-hand side, but my left-hand side is missing. Like, a lot. My left hand, oh, man. You forgot the minus. Guys, don't make me search this. Oh, God. Oh, please. You're from the middle of nowhere, Jamal. Yes. Let's have a look. What's going on? I lost the minus. Where did I lose the minus? This. Amazing. I was wondering why this is like so weird, right? Guys, I found it. Thank you for sharing that with me. I think like when I'm doing this on the iPad, I want to blame the lack of friction on the iPad. We're just writing things too quickly, right? So clearly it's the iPad's fault, not my fault. That's a minus sign there. So what really happened is that there's a minus sign there, which means there's a plus sign there, which means it's plus and it's plus, and we got everything. I was missing a whole factor of 2. I was literally gaslighting myself going, did I forget to like, do a half when I like differentiated or something like that? No. All right, thanks guys. I can even make it. I've got a good 55 minutes to keep going. So let's go 15C. Oh, there's 2 of them? Yuck. Oh, 15C. Do I want to do this question? A bar magnet is held vertically. Object that is repelled by the magnet is to be dropped from directly above the magnet. Will retain a vertical trajectory. That is repelled by the magnet is to be dropped from directly above the magnet. Okay. Right, okay, they got the diagram. Why is there 27g on x cubed? Alright, they even gave us the total acceleration, so we're going to take it. Why is g part of this? Like, I hate when like g is part of acceleration. But, okay, whatever. What am I, like, that's the same thing I had with pulleys. What am I doing? Okay. Show that v squared. So, guys, I mean, look, the thing is, like, in the earlier question we did dv dx, so I'm going to have a guess, and it's going to be d half v squared dx equals to 27g over x cubed minus g. So 27g x to the power of minus 3 minus g half v squared equals, we're going to integrate that on there real quick. Okay, so integrate that, 27g x to the minus 2 over minus 2 minus gx plus c. And release from rest at x equals 6. So v equals 0, x equals 6. These numbers don't look nice though. V equals 0, x equals 6. I have a 27 on 36 g. No. 27 on what? 72 g and minus. This is gross. Like, am I doing this right? Like, we got 3 on 8 minus 6. Minus 3 on 8. I'm too scared to do this fraction in my head at this point. Minus 51 on 8g. Yeah, they got 51. Yeah, no, they got 51. Nice. Okay, we're on the right track. So half v squared equals. I love when they at least give us something to get marks in, right? So 27g on x squared, I think, 2x squared minus gx minus 51 on 8 of g. Multiplying across both sides by 2, we have minus 27g over x squared minus 2gx minus 51 on 4. I think that's everything they got. Yeah, factorize the g out. Alright, we're sweet with this question. There's nothing crazy going on here. Great. Okay, that's all there. Yep, it's all there. Find part 2. Find where the object next comes to rest and give your answer to 1 decimal place. Find where. I'm like wondering, is they just care about v equals 0? Because if v equals 0, this is just a cubic. Like, I can't see how this can be any hard. I'm going to delete the g as well. Minus 2x minus 51 on 4. Multiply everything across by. Why are they asking us to solve a cubic at this stage of the exam? Like, am I like missing something, or is this actually what they intend for us to do? Did I just lose something? Yeah, I lost the whole x squared, guys. Okay, so let's just move it all to one side. So we got 2x cubed plus 51 on 4x squared plus 27 equals 0. We're going to times everything by 4. 8x cubed plus 51x squared plus what is this? 108 really equals 0. What? No, I'm missing something. We know that x equals 6 is a solution, isn't it? Let me just, what? Did I lose a whole minus sign? Yeah, I did. Yeah. They got a plus 51 on 4. Where's my plus 51 on 4? I lost the whole minus sign. What is going on? Yeah, guys, I've lost the ability to find C. Oh, man. Okay. Oh, plus C equals 0. C is plus. Like, I didn't even check. Yeah. That. I was like, there is no way that I'm solving this cubic if I don't have at least one solution. Guys, I want to check chat. I'm going to look up and check chat right now because this is disgraceful. Like, I've never had, like, this low accuracy. Trust me. Like, this is awful. I lost twice 2 minus signs on questions that, I mean, I think I know how to do. My goodness. Minus sign. All right. So, Daniel said I tried perfect square and got some answer. Look, because the reason what I was about to do was I was about to check x equals 6. I know x equals 6 is an answer. So we're going to like do some division, right? So we're going to do some suspicious synthetic division here. 8 minus 51, 0, 108. We're going to quickly do a long division by the root of 6. And we're just going to go for it. 48, 3. Wait, what am I doing? Does this even work? 6 is not an answer? Am I like, what am I doing now? 8 times 6 cubed minus 51 times 36 plus 108. It's 0. Yeah. Have I lost my ability to long divide? I think I have, guys. I think I'm so done. What am I doing? Yeah, I've lost my ability to long divide. That's amazing. Yeah. What can I say? Guys, I can't do long division anymore, at least in this manner. Let's do long division like how we teach it to the kids at school, huh? I can't believe it. So 8x. No. Guys, teach me how to do long division again. What? What am I not doing? I want to just keep doing long division. Yeah, okay. I even checked that it was a root. I don't know what's going on, guys. I literally checked that it was a root. Why am I like stun locked by a long division? I don't know. I don't know why I'm stun locked. 8x squared. Someone said 8x squared. Yeah, 8x squared, yeah. Yeah, but like, what? Why can't I long divide? I just checked on the calculator. It divides through by x minus 6. Bro cannot do what 10th grade. You know what, Jamal? You're right. He's actually cooked, brother. Oh, yeah, 8x squared on the quotient. Yeah, but like, what's going on? Am I not willing to do this? Like, do I just refuse to do the subtraction properly? Let's keep going. Let's just keep trying. 3x cubed. Okay. Yeah, and then what? Oh, I mean, you just have to believe, guys. I just didn't have the faith to keep multiplying. My goodness. So I'm sorry, guys. Sorry, it's been a long day. It's been a long day. You know what they say? Yeah, that's awful. Okay, guys, in my current state, I can't even do long division. I've just been sitting here attempting to do long division for a good like 5 minutes. All right, at least we got it. Like, this should not be a question with any issues, but I don't know what's going on. We're gonna solve the rest of it. We're gonna get a 9, 4 times 8 times 18, okay, plus 576 over 16. Yeah. I mean, like, this number's weird. Look, and really honestly, there's only one answer that works here, because we don't want the answer that's bigger than 6, right? So we're gonna try, let me just check, 3 plus root 585, because we don't want x to be negative either, right? Divide by 16. Yeah, okay. We take the positive answer, 1.699 dot dot dot. Yeah, taking the positive. Should not have wasted that much time on that. All right. Sorry about that, guys. Holy crap. Joshua, don't listen to Raghav. Joshua Bigland, you got this. Thanks, mate. I appreciate it. I can't believe I just sat there doing long division for like 2 minutes, like 5 minutes. How are we going for time? Yeah, we got time. I'm just trying to hurry through. Using a suitable substitution on a question 15D. All right, what do we got here? 2x minus x squared dx. Why do they give it to us like this? Right? Like, why not cancel the x out? Or are we even allowed to? No, we can't cancel the x out. Yes, we can. What? I'm not keen. Why is it like this? Look, I know there is one thing that we can do. I'm just gonna try it, okay? Just because sort of like we're feeling edgy sort of tonight. All right. So what I'm gonna do is I'm gonna take the 2x, and I want to just write minus in front of the x squared minus 2x. I want to do it like this, and I want to do a plus 1, and then I'm going to do a minus 1. Okay, just trust me on this one. Let's just give it a go. Minus 1 plus 1 dx. Yeah. Did they even say otherwise? No, they didn't. Guys, what do you think my substitution is going to be? What am I angling for? I'm not buying it anymore. But you know what? No. We commit. Guys, let's commit. All right. Yes. Because, this is 15D. We're not stuffing around here. We're not like, doing like, 3-unit in substitution stuff. We're doing like big kid maths right now, okay? So we've got 1 plus sine theta squared over, like, you know what? We'll take the cos theta, right? So we've got 1 minus sine squared theta, square root cos theta. We got a d theta, so dx equals to cos theta d theta. Nice. Cos theta d theta. Is this, am I good? Am I good, guys? Did I do good? I think I did good. Holy. All right, now we're cooking with gas. First try, guys. First try. Use T-sub? Guys, I don't believe it. We don't need T-sub for this. This is just a trig integration. 2 sine squared theta is 1 minus cos 2 theta. Unless I've like missed something completely and I'm like really cooking, right? Like, and everyone's like just laughing at me right now. They're gonna be laughing for many years at this point. Yeah, so it's gonna be 3 theta plus 4 sine theta. All right, so minus 4. Yeah, I hope I know how to integrate this. minus a half sine 2 theta d theta. Okay, let me remind myself what this is. Sine theta is equals to x minus 1, yeah? So we've got a Pythagoras triangle with x minus 1 and a 1, and so this will be that thing that we had before, right? So we know that it's 1 minus x minus 1 in bracket squared. Okay, which is going to be the root of all that again. So minus x squared with a 2x. Pretty much our denominator from before. So let's do this. Theta equals 3 inverse sine of x minus 1 minus 4 cos theta. Cos theta is going to be the adjacent over hypotenuse, so minus 4 root 2x minus x squared. Sine 2 theta, we're going to have to do like the half business, yeah? We're going to have to do the other thing. So minus the double angle formula, so we're going to have x minus 1 multiplied by root 2x minus x squared. I reckon we'll leave it like that. I feel like this is good. He's cooking. Yeah. Plus C. So, you know what? Like, that was a pretty successful 15D integration. He'll put C at the end, probs. Yeah, thank you, Sandy. That was sick. Did anyone do this any other way and it was cleaner? Because I think this is as clean as I could get it. Like, I cooked hard on that one, guys. 15D integration. We got it. Question 16. Let's go. Let's go. Let's go. Yo, what did I get on the 2023 HSC? Less than 92, I think. Less than 92 raw. There was a few things I can't get. I couldn't get the one at the end. It was hard on time conditions. I think I might even do worse on this one, to be honest, at this rate, right? We're about like 40 minutes out, so we'll see. 40 minutes for question 16 is not a good look. Yeah, don't lose marks if you forget plus C. You subbed in x equals to 2 sine squared. Oof. Oof. Oh yeah, I can see why you wanted to do that, because that way you can get like a whole pile of like trig equals, yeah. But guys, this is a thing. This is a secret thing. If you haven't seen this before, when you see that, your sort of senses for the concept of like trig, like there is something going on. This could be an inverse sine. This is literally inverse sine. If you haven't seen this before, if you ever see this sort of thing, you just think inverse sine. There is some inverse sine, inverse cos kind of thing going on. Okay? As you can see in the answer, we did have inverse sine sitting right on top of it. So it's a matter of learning how to get it into that particular form. All right, 16a. Consider the function. So this is the question with the weird sort of diagram situation. I'm just going to switch to the other screen. We've got some crazy stuff going on here. Show that k is greater than 1. Okay. And what is this circle? Is there a unit circle? No, it's not a unit circle. Let's say the vector joining the origin to the point AB, okay, sure, yeah, whatever, is perpendicular to the tangent to the graph of the function. All right, look, this is very doable. I think I'd say like this is very doable. So we're gonna just chill, right? We're gonna go y equals to, I wanna go back to the writing pad. Y equals to cos kx, y dash equals to minus k sine kx. At a comma b, we have y dash equals to, so we're going to get the gradient going first by subbing in a. So minus k sine ka. Fantastic. So we got that going on. Now, this is the gradient. What we want is we don't want the equation of the gradient. We want to treat this like some sort of rise over run situation, right? We want to go ahead 1 and go down by k sine ka. Okay, so that's the thought process of what's going on here. So the vector that we're going to do is 1 minus, this is the minus signs, oh boy. And we want the dot product of this and the vector AB to be perpendicular, so it's 0. So we got A minus BK sine KA equals to 0. Let's just check what's going on here. So I've got an A equals to BK sine KA. and a over bk equals sine ka. Show that k is greater than 1. Okay. Interesting. K is greater than 1. I'm kind of like concerned about this. Why would this be a thing? Perpendicular. What have I not done yet? I have not done something else. I haven't actually done the fact that AB lies on the thing. So let's put it in, okay? So B equals to cos kx. Yeah. Of course. All right, cool. So just doing this products. Yeah. Because we did the gradients. You know the good old advanced maths thing where like they give you the gradient and they give you the point. We just have to sub in the point. All right. Equals 1. So a squared on b squared k squared plus b squared equals to 1. We just have to make k squared a subject, surely, right? How? So a squared on b squared k squared equals 1 minus b squared. I'm just gonna like maybe move this guys to the other side. 1 minus b squared equals to b squared k squared, and k squared equals to a squared on okay, b squared 1 minus b squared question mark. Why? Oh, we know they lie on a circle, right? So 1 minus b squared. But what's it got to do with a circle? What's so good about a circle though? Okay, guys, hear me out. We know that when it comes to a circle, the thing about a circle is that the Pythagoras of A and B is an invariant, right? So surely this has got to be it. But how? Why is it 1? Oh man, like it looked so good. It looks so good at this point. Like, let me just think. All right, guys, we gotta think. We got a 1 minus b squared, and it's not looking happy right now. Is it 1? It should be. Okay, I'm just gonna quickly check my algebra. We've got this. Yeah. We got b equals to cos ka. Yep. Okay. So this looks good. I mean, I'm almost like, you know what I'm about to do, guys? I'm about to do something really stupid, like AMGM or something, you know, at this point. But let me just give that angle a shot. Let's go over here. AMGM says that we have greater than, yeah. Okay. So a squared, b squared, k squared plus b squared is greater than equals to the multiplication of these guys. So square root. And what is k? What is k though? There's something special about k. I still can't see how k is like greater than 1. Nah, it's not good. Did they say unit circle? That would be so nice if it's a unit circle. Oh, guys. A squared plus b squared has to be less than 1. Look at the diagram. I mean, this is like a cos with amplitude 1. Of course, right? Like K. We're back in it. We're back on it. All right, guys. So let's just replace a squared out. A squared is less than 1 minus b squared. So what we can say is that but we don't want great. Oh man. That just makes us smaller. Let's just play the algebra out first. No, b squared's not going away. Look, I think I'm really close. But I can't see it, guys. I can't see how 16a can get me to go, right? So I don't want to spend all my time on this. I've got half an hour to try the 16b, and how far do we got? B and C, so there's 3 parts. All right, let's do B. Let's do a chill complex numbers question. I'm gonna leave this one for now and come back to it because I think I'm on the right thing, but I'm just not sure. Okay, let's do B. Root of unity. The number gamma is a cube root of W. What? Excuse me? So W is e to the 2 pi 3i. Lovely. Okay. Cube root. Yeah, sure. Gamma plus gamma bar is this. Is a real root of this. I mean, I know where this is going, but do I? Cube root of W. Do not make me do this. Oh, no. This is not fun. Guys, this is bad. This is bad. Are we really gonna go for this? I feel like there's no choice, right? We're gonna have to. Okay, so let's go. I'm gonna just speed it. Like, gonna speed run past this one. Okay, so E, we're gonna go 2 pi over 9. And it's a, did I say complex root? No, it didn't. It just said that. Okay. Let me just fix that up a little bit. Okay, whatever. But honestly, isn't that just like 1/9, except like with some more rotations? Whatever. Just sub it in. LHS equals. All right, this should work out. This is just W1 and W anyway, so it doesn't really matter. Okay, this looks chill. I have a good feeling about this little section here. I'm just gonna factorize this little bit again. Yep. Oh yeah, cool. That's gone. That's a 1. So these guys are gone. That's a 0. Plus 1. And over here I've got gamma cubed plus gamma cubed, and that's you know, W, and the other one is going to be W bar. Now plus 1. Usually W bar is always the W squared, okay? Like, take my word for it. I mean, it's true, okay? Like, if you want to do the cases, you can do case 1, W equals to E. Oh, they gave us just one case. All right, easy. That is the case. Great. All right, that was the easy 3 marks. I told you we'd relax on the complex number stuff. This is just a straight sub with some algebra. Easy. By using part 1 to find the exact value, what? Exact value of this. Yeah, okay. Sure. Okay. Right. Oh, God. All right. I confirm I got 14 out of 14 for question 16. Nice. Swifty, I haven't even done 14 out of 14. I haven't even done for question 16. What are you on about? What are you even on about, guys? All right, so here we're gonna actually list out the possible values of W, okay? Sorry, gamma. So gamma, we have e to the I. So the first answer with n equals to 0 is 2 pi over 9. It could also be e to the I. The next one up is going to be, I don't really want to do this, like it looks bad, but I'm going to guess it's 4 pi on 9. I'm just going to quickly check. 2 pi on 3 plus 2 pi, that's going to be 8. Yes, 8 pi on 3, which is 8 pi on... Alright, no, we're going to do it slowly. 8 pi on 9. And if that's when n equals to 2. 1. And n equals to 2, we got 2 pi on 3 plus 4 pi. which is going to be the next one up. So 12 pi, 14 pi on 9. Okay. I'm just not liking the look of the 14 pi on 9. It looks bad. Because none of this looks like conjugates. So we got that. Okay, so it's one of these. Now we know that that is a real root. So what we know is that cos gamma plus gamma bar equals to 2 cos 2 of the real part of gamma, right? Which equals to 2 cos 2 pi on 9, or 2 cos 8 pi on 9, or 2 cos 14 pi on 9, and I'm pretty sure 14 pi on 9 is what the other guy is, which is the 4 pi on 9. How they get 4 pi on 9? Oh yeah, because 18 pi on 9, so it's negative. So this is actually, this is equals to 2 cos, because it's a fourth quadrant version of 4 pi on 9. Easy. Okay, so these are the three roots, and we have, by using find to find the exact values of this, yeah, we got it. So the product of roots is going to be 8 cos each of these three things, right, that they wanted, which equals minus 1. So this product is minus 1/8, which is pretty predictable. Like we knew that this was going to happen. The gamma thing was cute, sure, but this was fine. Minus 1 on 8. All right. So now deduce the values of this. What? Oh. Wow, interesting. I know, like, I get the feeling I know where they're going for with this one. So because if you take the next one up, right? So if you went up, so as soon as you cycle to the next one, 16 pi on 9, guess where you're at? You're back at sort of like 2 pi on 9. So how much proof do we need to give that this is going to be true? So if n equals to 1, we've already got the answer. If n equals to 2, we got this one. So cos 32 pi on 9. I wonder if they require a proof for this, actually. This is going to be 36 pi on 9. So it's going to be cos 4 pi on 9. And so on. I feel like it cycles through. It totally cycles through. Like, this is not a problem at all. Like, this can become the next one. How do we prove that? I'm going to say that it's got to do with the fact that I'm just going to write this for you guys, okay? So we got cos 2 to the n pi on 9 plus, no, not plus, cos 2 to the, I wonder how much justification you need, because I'm going to say that the answer is minus 1 on 8, like completely, because they're the same, right? Like, just intuition tells me. But how much proof do the markers need that you can, like, justify that all these things are the same? I'm just checking. So you can look inductively at this, and you can say that the moment we get to, I'm just checking what's going on when you get to like plus another 1. So that's cubed, right? Cubed is the same as, yeah, okay, 64. I want to check one more time. Hold on. 1 pi on 9. Whoa. Hold up. No, there's more to it than this. All right. Values, right? Plural, guys. Values, course. All right, fine. Ridiculous. So again, this one goes up to the next one, actually. 9. So pi on 9. What are we on? You know what we're going to do? We're going to do this. We got this one. Cos. Oh man, I feel like it sort of alternates because then the next one's negative and it's like it alternates. It goes 1/8 and then it keeps on going. So I'm just checking out what 64 is, but I'm like really tired now. So what's another multiple of like 9? I'm just gonna write these out. Okay, so 16, that's 18 on 9. The next one up is gonna be double that, 36 on 9. The next one is 72 on 9, which means that this is cos 8 pi on. No, it's the same thing. What's up with that? Like, so if I went to 16, I get 2. If that goes up one more, no. Yeah, that goes back to 2. And then if I took it up one more, look, I don't know. I feel like it's just 1/8, minus 1/8, and it could go to 1/8 maybe. But I'm just gonna have a break on this one. I think that's fine. Like, I don't know where the 3 marks are coming from, but there's like definitely 2 answers to this. And it says justify your answer. So let's have a look. Do we have time to do the last question? Yeah, we've got about 20 minutes. All right. I thought I was alone. Please, the answer is minus 1/8. No way someone else was using an abacus. I don't need to live. Hey, Swifty, bro, if you're on like 91 raw, you're doing really, really well. I want to just talk about this though. Like, I have a feeling I agree with you. It's just minus 1/8. But I don't think they said justify. Like, you need to somehow find a way to explain to them that this will stay the same over and over. And I feel like the way to do that is you need to find like ways of talking about like 2 pi on 9. Like this idea here. If you have a look at these particular examples I've written, right? This is like 16 pi on 9 was like 18, but 1 less. Like I just don't like this idea of this 2 pi. Like, it's just really bad. What is it about number theory? Like, you got 18, 36, 72. These are like the key numbers, and somehow these numbers all fall really nicely around that. Why is that? They're multiples of 18, but why? Okay, so the justification is going to need a bit of work. I'm happy to just do some mechanics at the end. Let's try the last one. Nano Music got 3. I got minus 1/8, but left the justification. I feel like it's 2 max. I'm positive. I'm like optimistic it's 2, but I'm still not just able to justify it yet. I'm hoping it's a 2. Okay, so let's do 16C in 20 minutes. Are in a medium that exists. Okay, sure. The way I like to do this, right, especially because they're meant to meet, is that I want to just deal with them in 2 separate directions, because I think doing the same convention is going to make this more nasty. Okay, so we have a KV is the resistance, and so for particle B, okay, we're going to move B in that direction, and we're going to call this direction positive. So it's going to be G minus KV. Okay, and for A, we're going to treat up as positive. So we're going to have minus G minus KV. Those are the 2 things I like to use for this one, just because I think it's a good way to go. Okay, find the time taken. So, okay, great. Let me just check something else. I feel like all these things are useful, but I'm just not sure what to do with them just yet. Okay, we need to find the displacement function for the both of these. G minus KV. Yeah. Okay, let's do the displacement function for the both of them. And we're going to treat each of them as having an initial displacement of 0. So, what do we choose? V dv dt? Nah, dv dt. dv dt, not v dv dx. We kind of need both, actually. We need both. Okay, we're going to have to deal with both. Okay. This feels like good old, mechanics questions. I don't know if there's anything to this. Times by minus 1 on K, and we're integrating. Okay, so great, integrate dV. Minus 1 on K, ln G minus KV plus C with a T for time. Okay, And for this time, what we're going to have is we're just going to let t equals 0, v equals 0. And that should give us a 0 equals to minus 1 on k ln of g plus c. So c equals to the minus. So c equals to 1 on k ln of g. And we're going to put this as t equals to minus 1 on k ln in thingy g minus kv on g, because it's a minus minus, right, for this c. So that's that one. And we're going to do the other one with a minus g. So similarly for a, I'm going to try to save as much time as I can by leaving out the thing. So the t for a is going to be exactly the same, except the g got changed to a minus g, just for the sake of time, right? So kv. And on the bottom, I'm just going to be a bit careful here because it's minus g. It's an absolute value. It doesn't make a difference, does it? So you can call it minus g here if you want. Okay, so that's the two time equations. I'm happy with the thing. I'm going to leave them there because I'm going to go to the displacement ones now. So we're going to go v dv dx. G minus kv. Divide through. Got g over v. Nah, I feel like going back to the other side is better. So g minus kv dv times 1 dx. These are like not that fun to integrate. Like I find them very like tedious. How do I do this? Do we want to times? I don't know, guys. Like, are we gonna really have to split this? Like, oh man. Okay. All right. We're gonna split this by multiplying 1 on k out. Right. So we got minus kv on g minus kv. And what we need here is we're gonna do a plus g minus g. I feel like I'm chasing like a dead end, but like there's nothing, we just have to go with the flow. It's 4 marks for like doing just really boring integration for like ages. You know, like how's the market gonna just be entertained by this? I don't know. Like, are we just wasting time? I don't even know anymore, right? Like I can't tell if we're wasting time or not. Yes. So that's a 1 minus g on, oh, come on, another one of these. So we're gonna have struggling here. So minus 1 on k, 1 plus g on k, blah dv, which equals to minus 1 on k ln. No, we got a v first, plus g on k ln of g minus kv plus c. And that was for x, by the way. Yeah, x. Okay, cool. So that's x. And we know that when v equals 0, wait, what was the initial velocity? v0. Great. v0. I don't want to do this. This looks bad. This is bad. Like, where is like even the distance between them? D. Right. This looks bad. I'm not keen. I don't want to do this. So let's just try. Let's just try to do it. And here I probably made a mistake as well. So I'm like, this is terrible. C is all of that. Really? Anyone like help me out here? Like, how much time do I have left? I've got about 12 minutes. Yeah. 12 minutes. 12 minutes. But honestly, guys, like, I don't know where this is going. Like, I've just integrated every single thing under the sun on this topic. Like, do we really have time to do this in 12 minutes? You know what my plan is? Like, I'm planning to like put this into this, right? And then afterwards, all right, you know what? Let's just tank it. We're gonna try doing it anyway. Minus 1 on k, v plus g on k, ln right? We're gonna just suffer through it. Okay. Plus 1 on k v0 plus g on k ln g minus k v0. Right, okay, cool. The other, so this is for particle B. So particle A, we're going to replace the same thing but with a minus g. So v minus g on k. I think there's something more clever I'm just not seeing. Like, this has got to be more than just like this kind of concept of just repeatedly integrating everything. G on k ln minus g minus kv0. Okay. All right. So what's the big deal? Well, these guys have to apparently add up. Oh, add up. Add to d. Yeah. Okay, cool. So let's go here. We're cooking again. This, no, we're not cooking. Like, got different terms, guys. What is going on? Oh man, they don't add at all. I'm sorry, guys. It's not going well. Like, how? I'm gonna add them anyway. With a 2. All right. I cannot see how this can go anywhere. And there's a minus sign here that I lost as well. Great. No. And this is meant to be D. Wait, no, because of these minus signs, like, I'm just looking. There's no hope, is there? Nah. Let's go back up to the original 2 velocity equations. Is there anything useful for us for these guys? The time equations, find the time taken for the particles to meet. When they do meet, these guys have to be like, we got to put the V's in. Yeah, nah, I don't think I can get much of 16. Like, how many marks do you think this is worth in 16? I've literally like wasted a whole, like, what, 12 minutes just integrating blindly. Anyone? 2022 was the hardest if you look at scaling. Why don't you just equate the 2 of them? You can't really equate them because I'm actually doing like the I didn't use D. I had to add them to D because I defined the direction conventions differently at the start. Right, so we're gonna have to deal with this. So I'm just gonna go back. We're gonna go back and have a look at things that we can maybe pick up some more marks in. So this is a giant question mark. I don't even know I'm going in the right direction. So let's go back to the attempts. So this was bad. We didn't get that. We need to justify. So we got a -1 on here, question mark. Okay. This one, show that k is greater than 1. Did I even get that cleanly? I think I did. Did I? I forgot. No, no. So I have to ask myself, how is this going to get there, and how far did I even get with this part there? So there could be a lot of marks lost. I feel like all these other stuff was okay over here. Comes to rest, yep, suitable substitution. That's fine. I got the substitution. Everything here is never a cube root. Yeah, that was fine. The middle of a triangle. I still haven't done 14E part 3. Find OT in terms of this. So what a pain. I can target 14E or I can target question 10. What do you guys vote? Can we get a vote? Who wants me to spend the rest of the time on 14E or 10? Or we can spend more time trying to like figure out like what on earth is going on with 16A. 10. All right, we got a lot of 10. I don't want to do 16C. I'm sick of 16T. 10 is only 1 mark. 10. Oh, so many 10s. All right, guys. Let's get on 10. I might even try to get like the pulley one right at this point. Okay. So 10. 10. Let's go. Question 10. All right. What is this on about? Let me just try to do 10 at the end of the integration. I don't think I can do this like question 16 in time. So let's try to make 10 happen. So what do we have in 10 and what's actually happening? So we have 3 unit vectors. It's chosen that A dot B equals 0, B dot C equals 0, and the angle between this is as small as possible. So when we talk about angle between, we can discuss it in terms of A dot, so we have this, cos theta, that's the angle. We want this to be as small as possible, and that should equals to A dot the following, yeah? So this is what I've got so far, and I've got A dot A, which is a unit vector, so it's just 1, A dot B, which is 0, so it's gone, and A dot C, which we don't know anything about, okay? So so this is just 1, and this is 0, A dot C. I want this cos theta to be as small as possible. What else do we know? We know that they have a magnitude of 1, and what have we not used yet? We haven't used B dot C equals 0. Is there a point to doing that? Small as possible. I'm still like leaning towards like squaring everything actually. There's got to be something that goes beyond. 14E is easy, but you do the same thing you did for I. Yeah, I'm just like in the middle of like, I think just doing too much. I don't think I can actually get 14E. But let's just finish off on a strong note with getting 10, eh? Let's get 10. Okay, let's get 10. Dude, what's happening? Anyone got more insights to share on 10? Like, what is this? And how can we make it work? I'm sort of thinking maybe we should like square it. That's just 1, isn't it? That's just 1. So we basically have A, B, and C being like the sum of these 3 vectors, and we have cos theta equals to the 1 over 1 plus A dot C over okay. Do not make me do this. Do not make, guys. Okay, let's go. I got nothing to lose here. Let's go. This. Okay, so 1 plus 1 plus 1 plus 2. Yeah. Okay. All right. Now we finding something. Maybe. All right. All right, 3 plus 2. All right, so what do we got as the zeros? We got 2 zeros. Wow. Okay. So let's say A dot C is like K or something, right? 1 on K squared. 1 plus 1 on K, sorry, and 2 plus 2K. And that's cos squared theta. And honestly, I just need to make K what? Like, I've literally got it. This has to be it. Like, I cannot believe that this is anything more than this, right? So what is it? Let me expand it. Plus 1 on 3 plus 2K. How do you make this as small as possible? To make theta as small as possible is to make this as big as possible without blowing things up. How do we make this as big as possible? Let's try some numbers. All right. So if I choose K equals 1, so A dot C equals 1. That's like an endpoint, right? Because K is equals to A dot C. So when you do like something like this, the sort of the like itself is this. Let's say cos of alpha, right? So we got K equals to cos alpha, the angle between A dot C, right? So we got So the maximum k is going to be somewhere between -1 to 1. So all we need to do is think about the range of this function from -1 to 1. Surely, guys, in 1 minute, I can just test the value. Let's go. If k was 1, we're going to get 4. Okay, so we put 1 in, we get 4 over 5. That's possible. If k was 0, we're going to get 1 over 3. That's possible, but we want the biggest one possible, so we want this one. And if k was -1, we're going to get -1, you'll get a 0. So that's no good. That's not good. We want the smallest possible, so we want this. All right, guys. Let's make this happen. Because cos squared theta equals 4 on 5. So cos theta equals to 2 on root 5. Look, I'm going to go with this. I'm going to go with D for 10. All right, D. Like, just because I've got no time left. And that's me, D. So, yeah, I guess I don't think I even broke 90 for this exam, to be honest. There's like some things at the end that were a little bit too much for me. So D is the answer. Mohammed's pretty sure. Yeah, like I'm on D. I've just ran out of time. I probably should have picked something better for this. Can we like just, all right. So that's the end of the little presentation here. I've sort of, I think I'd be lucky if I break 90 raw for this exam, just because like I got bogged down somewhere and there's some questions that I didn't get. So yeah, I guess that's what it is. It is what it is, guys. So talk me through at the end, if you guys are still watching. Mod got 10D in his solutions. Yeah, I'm just not sure like exactly why, right? Because there's obviously a nice way of doing it. Can everyone talk to me about 6? What is the deal with 6? Why is D not the answer for 6? Like, I've got a big question mark next to 6. What's going on over here? Attached to the ends of the string are masses of 9 kilograms and 5 kilograms as shown. Like, what's the acceleration of the 9 kilogram mass? Like, to me, I thought it was basic, but obviously it's wrong. So what am I not doing right now? Any ideas for 6, please? Oh, that's right. Oh my god. Oh my god, really? Oh, yeah. Okay. This guy actually forgot how to do pulleys completely. Oh my goodness. All right, guys. Thank you for that. Yeah, the tension force on the entire string is actually like 14G. Okay. All right, of course. And therefore, yeah. So what do we have? We have 9G going down, okay, and 14G going up. So the two forces is, that's not 5G, that's actually 14G on the rope. So overall, what? No, I'm still not seeing it, guys. Oh, but no, it's not 14G, guys. It's 4G. What am I doing? What? Okay, tension is the 4G. So therefore, no, I still can't do it. Someone help me out here. F net is 4G, but F equals MA. M is... How is M 14? Can you explain, Mohammed, why M is 14? Because like, I've never seen this way done like this before, where you take the whole system of the thing. Is it because the whole pulley, like the whole thing is like 14 kilograms, so the system is 14, and therefore you can just do it like, you know, the net force. That's why I thought it was weird, right? The F net is definitely 4G on down, but you're saying the whole mass is 14. But shouldn't they call this like a net force downwards? Like, they shouldn't be calling this like a, what's it called, a an acceleration, because it's still got G in it. Isn't this a force and not a acceleration? Or am I not seeing something? No, it's fine. Oh no, it's got G because we're just dividing by 14. All right, whatever. So what was 6 again, everyone? Bro doesn't know tension. Yeah, bro doesn't know tension. 1 net force. Yeah, no, I actually don't know tension anymore. I'm failing at this. So, should we go A? Yeah, thanks guys. A. Great. Yep. Look, I think my maths ability has honestly devolved in the last year. I don't know what the deal is. Okay, so I hope everyone's happy with this multiple choice section. And yeah. Question 8 got me crying. 8's not too bad, but 8's sort of like controversial. It's going to be like people are going to be arguing whether it's in the syllabus or not. Okay, it's just one of those ones. But can't even do tension. Unbelievable. Thoughts on the paper compared to 2023? What can we say? Like, I'm going to say that I think this is harder. I don't know whether it's because I got distracted throughout the middle of the exam and started running down my time a little bit, but there are things towards the end of this, like in multiple questions in 16, that I can't clean up, like all the reasoning. Like here, I thought I was close, but not really, right? So, in fact, I know 14's a chore. Like, if I had more time, I can get OT. That's not really a problem. But 16, who's got an actual answer for 16A? Show that K is greater than 1. And how does it actually work out? Or we might just actually go look at mock solutions, but I kind of don't want to get it spoiled. I'd rather find out for myself. So, and I think there's just little bits and pieces of 16 that were a little bit hard to completely close out. Whereas last year, the only really hard one was the very, very last one with the crazy complex numbers. Whereas this one, I don't know. Is this like a good question? Question 16C. Did anyone get 16C out completely who can like definitively say that I'm totally thinking in the wrong way about this? Or is this just really an integration fest? What's our view on 16C? 16, you had dot product equals 0. It cleaned up. Okay. Wait, sir, for question 15C part 2, did you actually have to solve that dumb cubic? Yes, you did. Yes, I did. So Muhammad reckons it's an integration fest. Yeah. Honestly, I like last year's last question better than. Like, I just wasn't in the mood in 20 minutes to do this question. It's like, it's just, I feel like they're going to be generous probably on getting some of those equations going, but I couldn't close it out. So, look, we're getting on to like 9. The final answer's nice. Yeah. Look, I will spend some time probably tomorrow just working through it before I have a read of mock solutions. I'm sure mocks had a more like relaxing time doing this than doing this on display for everyone. Honestly, I think I did worse this year than last year, and it is what it is. All right, and I think we just have to own it. There are just things that I couldn't tidy up in each question in 16. I don't even think I got 6 out of 6 for the 16B. So it is what it is. Band 6, 68 raw. Look, considering I did worse on this one, and there's plenty of things that were very hard to find, like insightfully. Like you could waste 30 minutes on 15D, right? You probably will be okay on this one. This one's not bad at all, 15C. This one, not too bad. The vectors can also spend a lot of time, especially like this triangle business, right? So I would say that comparable to last year, this year's harder for me. So hopefully your 68 raw can get you a band 6. The answer was, yeah, but are you sure it's just -1 on 8? And why? To justify your answer deserves at least 1 out of 3. And I don't have the time to like cleanly write out the justification, but I'm pretty sure it was so close. Like I wrote out some like patterns and it's like all the same, right? Yeah. So, what's a 90/91? Muhammad, like I think chances are that's probably what I personally would have got, maybe a little bit under. I hope it's like a 96, 95, something like that if you multiply by 2, because it keeps on Yeah, but is that enough to prove that it works for all integers? Because, like, as the powers go up, you somehow have to justify, like, really rigorously that it actually continues to be those values. I'm pretty sure it does. I feel like you can do it for the different powers and say that because it's like a group of 3, right? There's got to be some pattern to it. And you know that when this goes up, this one would replace that one. So chances are the 8 pi on 9 is the thing that helps you get it. The extra multiplied by 8 at the end. Somehow it helps you get it because it'll be the other one, I think. Yeah, but I'm still thinking about it. Okay. Yeah, my explanation for the period is wrong. Which one's the period? Yeah, for 2k to the k plus 2. Yeah, I think you might be right. I'll see you on... Yeah. Brother, 3 unit hopefully is more cozy, right? We're all looking forward to a cozy one. Hey, look, Amelie, we're going to give you a shout out, even though I'm going to remove the message. Okay, shout outs to Amelie, the chattest of all 4 unit students. All right, everyone, we're going to finish up right now. And yeah, hopefully everyone have a great night. I will check this out and try to tidy up the answers tomorrow. But yeah, good luck with the rest of your exams. Peace out. Bye.